Good morning, ladies and gentlemen. I'm not saying very many ladies, maybe ladies and gentlemen, probably. Welcome you all. I am Saraswati, Secretary General of the Madras Chamber of Commerce and Industry, and on behalf of the Madras Chamber, Oracle Consulting, and our other esteemed partners, German Cooperation Partners, Partnership Transformatives, Develop, GIZ, Ornate Solar, Oracle Consulting, of course, and Guidance, Indian Institute of Architects. I take pleasure in welcoming you all for this information packed workshop, I should say, for the next 3.5 hours. And thanks for joining. More to come, but I always feel we shouldn't penalize people who have been punctual. So we will start the program now. People can join. And just to give a very brief introduction about the Madras Chamber, the chamber is 189 years. I don't know to say old or young because we keep ourselves relevant to all the members even now. But we are another 1 decade from now, we will be hitting our bicentenary. And the chamber had been very active right from the beginning. If you see the history book of the chamber, which we released during our 175th year, many of the infrastructure development we could proudly say had been possible because of the chamber, whether it is Southern Railways, port, coastal telegraph, you can list the whole lot. And also many of the policy reforms, I would say, again, had been promoted, advocated by the Madras Chamber. And in fact, one particular thing I should say, we did a study some time back, and that opened up for the MNCs to come. We gave a very strong recommendation again many years back. And history again says that after that, the Ford was invited, the first MNC to come in and set up office here. And now you know the kind of developments happening in Tamil Nadu and in Chennai, in particular Chennai and Greater Chennai. And Madras Chamber again very consciously positioned ourselves as a chamber for the Tamil Nadu, though we also promoted ASSOCHAM along with 4 other chambers like PhD Chamber, Indian Merchants Chamber, Bombay Chamber of Commerce and Industry, Cochin Chamber. We promoted the ASSOCHAM. But still, we very consciously, after a lot of deliberation, we thought Tamil Nadu itself is like a country and we can do enough and more in the state. So we are very consciously positioned as far as the socio-economic development aspects of the state is concerned. We said our first focus will be Tamil Nadu. And having said that, actually, with all the urbanization, Tamil Nadu, as you all know, is one of the most urbanized states. We have always been having a food for thought discussion, which is kind of a debate which we introduced in our 175th year, whether urbanization is a boon or bane, because it also brings with it a lot of challenges. But definitely, I don't think we can go back and say we don't want to be urbanized, because it also goes hand in hand with economic development. You know, now Tamil Nadu is a happening state. Many indices we are quite leading, whether it is socio factors or economic factors, we are always in the forefront. And that we can say to a great extent was possible because of the economic development and because of the urbanization which came along with that. So, given that thing, the kind of challenges that is also coming up because of the urbanization, we started our Sustainable Chennai Forum during our 175th year, and which very clearly focused on 5 pillars, we say: energy, waste management, water, urban greening, and transport. And under each of this, we had been having number of activities, not just the conferences, roundtables, hand-holding exercise. In fact, we have a program called Responsible Cleaner Production Activities every Friday. At least one aspect of the sustainable development or cleaner production we focus, could be water, could be energy, safety, and we have continuous program. This is just an example. So this particular program, I'm very happy to collaborate with Oracle Consulting. Madras Chamber has always been working very closely with the Oracle Consulting, and we are very happy to organize this program today here. And it's a very naive subject, if I can say, because many of our own members were asking when we sent out the circulars what this means, what is this BIPV means, because it's fairly a new concept, if I can say. Though the chamber, though the state has been a leader both in construction development, real estate development, as well as the renewable energy side, this looked to be a little different for many of the members. So we thought it is worth having this discussion today. So as I said, we have a very packed time now. So I'm not going to take much time. We have around 700 plus members, direct members, and another 800 plus indirect members, the value chain members. So I also invite those of you who are not part of the Madras Chamber probably can consider. We can share more information to you, like the Ornet Solar, and I don't think you are part of us, though we have the other company. So I should also do a bit of a marketing pitch here. So thank you. So I wish you all a very, very productive day, and I leave it to Mr. Martin or Mr. Jain to start with the program. Any sort of interaction, I am sure we all want it to be more interactive, so we can use this platform and use this day for that kind of an interaction. Thank you very much. Wish you a good day.
Okay. Uh, Thank you, ma'am, for inviting us, hosting us here in Chennai. And say India was always the leader for everything which happened in North India. Yeah. But, yeah. So let me sincerely thank you all for coming. I hope your time which you will spend here will be worth, and you will have some more knowledge, insight from the national and global perspective. Myself, Avnav Jain. I am working as a senior energy advisor in German Development Corporation. Just a short about German Development Corporation because it is a new term for many of you. Uh, German Development Corporation is a PSU of Government of Germany, Ministry of Economic Development, uh, and it's a 100% owned company with the objective to provide developmental assistance to 120 countries across the world. And we work with central government in India, 23 ministries, and on all the topic of sustainable development and climate change related issues. And we support them in coming up with new policies, implementing the policies, doing capacity building, introducing new innovations for the India, also investment, technology transfer, and it's a not-for-profit institute. And the whole idea is to support government of India vision to achieve whatever they want to do in the sustainable development. Okay, now coming more close to the topic of BIPV. Everybody would think what this term is all about, why we need it. Let me take you back a bit to the journey, why we need it. I will give you some facts to, give a broader picture so you can understand where we are coming from. Right now, India is 1.4 billion people and having an electricity consumption of 1700 terawatt hour. Out of that 1700 terawatt hour of electricity, we are generating 250 terawatt hour from renewables and remaining 1550 or 1450 terawatt hour from thermal. We are expected to increase our consumption with our growth to 6,000 terawatt hour by 2050 and 17,000 terawatt hour by 2070 if we have to do net zero. All this 17,000 terawatt hour should mostly come from renewable, and those which can't come from renewable has to be compensated with the carbon capture and storage. While we are producing 250 terawatt hour right now, we say that we are already the second or third largest producer of renewable energy in the world, and we have only 200 gigawatt of installed capacity in the country, which includes mostly ground mounted solar, wind, solar rooftop, and some hydro. Right? And with 200 gigawatt of installed capacity, we are generating only 250 terawatt hour out of 1700. So only 20% or so. If we have to reach our target of even 2050 of 6,000 terawatt hour, we would need an installed capacity of renewables of 3,300 gigawatt. So from 200 gigawatt to 3,300 gigawatt we have to reach as generation capacity from all renewable energy sources. So the point comes, how you will generate this electricity, right? If the solar ground mounted system, which is already consuming or having competition with other productive uses from urban development, from agriculture, from other infrastructure, who will have the land first, right? Do we have enough land to use it? And do we need land to generate electricity? And the answer is no. You need sunlight to generate electricity, not the land. So the government of India 5 years back said that we want to explore new and innovative ways of using solar. And German Development Corporation had supported them to do a potential estimation of 6 new application, which is agri PV, so that you can do agriculture on the field, and on the top you can generate electricity. Floating PV, so you have your water bodies, your dams, your man-made lakes, artificial lakes, as it is, but you can generate electricity on the top surface. You have BIPV, so you have your buildings as it is, but their facade, which is also getting a lot of electricity, can a lot of sunshine can generate electricity. You have canal tops. So India has a network of more than 1 lakh kilometer of canal. You can use that to generate electricity. Roadside, rail side PV. So you have linear infrastructure of railways of 1 lakh kilometer, national highway for 80,000 kilometer. You can use the both side of these highways and the railways to install solar vertically and generate electricity. And urban PV, like in many of the urban scenario, carports and all these places. So these are the 6 new application we identified, and we found if we use a very small percentage of these all infrastructure, which we call dual use of infrastructure, we have a potential of 14 terawatt, 14,000 gigawatt. So it's not that we can't go net zero or we can't generate enough electricity to meet our requirement, but we have to diversify. We have to look differently, that we have to capture sunshine, not the space. You can have the same space with dual uses. So that was the idea, which now is getting into policies. You had already seen Kusum scheme, which is covering agri PV. You are already seeing floating PV coming in gigawatt scale. Now, a rooftop is already happening, but we are saying rooftop is good where you have roof, like in houses. But if you see all the urban development where you have high rises with all glass building, where you already have the top of the building covered with utilities and cooling system, and having a connected load of 1 megawatt, 2 megawatt, how they will generate electricity? So you have to use the facade, the solar skin, we say, that you have your facade, which you are already using it for architecture purpose, design, showcasing a message. Why don't you generate electricity? Then everybody said, it looks ugly. How can I put a black panel on my facade, which and my building, which is thousands of crore? So this is also myth, that it looks ugly. Today you will see that you can generate electricity in a cost effective way and make it beautiful. So once this concept is broken, you may find it a immense opportunity. We found in India, for any building which is more than 10 meter and above, and already those are constructed, if we will cover only those buildings, we already have a potential of 310 gigawatt of BIPV. And we are talking only about south facade, southeast and southwest facade. So we also considered that there is a huge portion, 44% of the building surface, which we will be not using, which is north, northeast, northwest kind of thing. So with these, what is the point? And then people say it's very costly. So we had done a cost calculation and said, what is the tariff at which commercial, industrial, and institutional consumers pay electricity tariff? It's already more than 8, 9, 10 rupees, 12, 15 in many places across India, right? If you right now, today, install a BIPV, which is still not a mass segment, you can generate the electricity at 9 rupees. You can't say it can be generated at 6, but at least those who are paying 9 and more, and anywhere close to thinking of replacing their roof of the industry shed trying to replace the facade or want to do renovation, they can just use solar panel. It's leak proof, it's colored, it's with texture, it's with glass. All these things are there. But this is not a knowledge that is available. So that's why we want to do awareness building. So today, this whole session is about providing knowledge and make you help you decide that what is the way you want to take forward. Thank you for coming, and I hope you will have a productive day.
Morning. Slogan then I lead Tamil Chamber of Commerce and Industry. So thank you, Mr. Abhinav, for the moments. So we are getting into our session direct. Now we are going to talk about BIPV as a building material. First, Mr. Shantanu Roy, policy specialist, says step to request him to come on stage. So here, Mr. Shantanu's profile. Please come on stage. And yeah, you can just have a seat. I'll just read it. Mr. Shantanu Roy is a policy specialist on the renewable and energy efficiency team at C-STEP, focusing on energy and power sector. He holds a master's degree in general management from the IM Indo and a bachelor's degree in mechanical engineering from the Institute of Engineering and Technology, CSJM, University Kanpur. Before joining C-STEP, he held key roles in the solar energy sector, including Deputy General Manager at Madhav Infra Projects Limited, Vadodara, AGM for Solar Rooftop at Ujas Energy Limited, Indore, and Manager at Reliance Jamnagar. His expertise lies in renewable energy and project management. Welcome, Mr. Shantanu Rai. I request you to give an presentation.
Thank you for your presentation. Yeah. Already slides. Where's your? Where's your? Have you? Sure. The slide change.
Sure.
Thank you so much, and thanks a lot, Abhinav, also for the excellent context setting. So makes my job easier. So I'll talk about the technical potential of challenges of BIPV in Tamil Nadu. So this is the flow of the presentation. First and foremost, why there should be a focus on BIPV. Majority of it has been already covered by Abhinav. We already mentioned that BIPV has been identified as one of the NISA's new and innovative solar applications. BIPV helps in utilizing your building space, maximum utilization of building space, and with that, it also helps reduce the carbon footprint of the building. It promotes energy efficiency. It helps reduce the cooling and heating loads of the buildings, and obviously the aesthetic integration is there, which he clearly mentioned that BIPV can actually make your buildings look more beautiful than they are right now. Then with that, obviously promoting sustainability in the urban areas, in the built environment of the urban areas. And then now BIPV is also a part of the PM Suryaghar scheme. So BIPV in the residential segment now is eligible for all the subsidies that a residential rooftop gets. So whatever that 30,000 for the first kilowatt and 60,000 for the next second, and then 78,000 for the third kilowatt, all these subsidies you are eligible if you install BIPV at your residence also. Now, this background, Abhinav has already mentioned. So, C-STEP had done this work for GIZ along with EY and Fraunhofer for this potential assessment. So, there's this portal called STI, which is the full form is Solar Technology and Application Atlas for India. So, you see there's a 309 gigawatt potential of BIPV. And apart from that, you can also see the national potential for the other applications. On this portal, you can not just check the India potential of all these applications, but also the state potential, also the district potential, and also the taluk potential. So this is the potential of Tamil Nadu, overall potential of Tamil Nadu here. As you can see, it's around 2 gigawatt, which is the confirmed potential. But then again, Abhinav has mentioned that it only considered the south-facing facades or southeast and southwest. So that is why it's mentioned as confirmed potential. But if you also start considering the other directions, the potential would be much higher. Now, just for Chennai district, you see the numbers there. And I have also put a screen grab of a particular taluk in Chennai, which is Egmore.
Can somebody switch off the light so that
Yeah, that will help. So this is what you see in Chennai, and similarly, you can also check for any taluk in Chennai, or for that matter, any taluk in any place of the country. So this portal is there for use. It's free of cost. Anyone can use it. It's called sty.cstep.in. You can access it there. Uh, in continuation with this project and with our continued association with GIZ, we also C-Step in partnership with the School of Planning and Architecture, New Delhi, had also worked on developing the first comprehensive guidelines for BIPV in India. So these guidelines cover the technical specifications of BIPV, types of BIPV, the design, the operation and maintenance, the installation, policy and regulatory, all the facets are covered. To access it, you can just scan this QR code. It's out there in the public right now, the draft guidelines, and probably by the end of this month, we hope that the final edition will also be out. So anyone, if they want, you can just scan this QR code and you'll be able to download the guidelines. Okay, so now coming on to types of BIPV system, because I think one of the primary purposes of this particular event is also to spread awareness about BIPV. So this, in very simple terms, you can see that this is how multiple BIPV systems can be installed. So you see first one, this is the facade mounted, which is the most popular of BIPV applications. So on the building facade, you see the first one. Then the second one, if you can see, is I think some help with the light. Yeah, so roof mounted and atriums and skylight is the second one, as you can see on the top right. Then the third one is on the balustrade, that is the balconies. Fourth one is on the window itself. Fifth one is the canopies and shading devices like awnings. And then the larger canopies like, say, carports or sunshades. What Now, what could be the potential drivers of BIPV in Tamil Nadu? So Tamil Nadu, as we all know, is one of the leading states in RE deployment. So it falls in the top 5 states in terms of overall RE deployment, which includes solar as well as wind, as well as all the other applications. Then Tamil Nadu also gets at least 300 plus sunny days in every year, making it an ideal location for solar installations. Then, as ma'am also had mentioned, that Tamil Nadu has a very strong local manufacturing ecosystem, which can actually complement BIPV production in Chennai, in Tamil Nadu itself. Then coming on to some other factors like, as per a World Bank report done, I think a couple of years back, 70% of India's building stock, which is needed for India to become a developed nation by 2047, is yet to be built. So you can just imagine the quantum of buildings that are supposed to come in the next, say, 22 years. Then there's a report done by CBRI, I think a couple of years back, that the Chennai building stock itself is expected to grow 1.5 times by 2030. So in the next, they did it in 2022. So in the next 8 years itself, it will go 1.5 times. And they have put some numbers also. So from 246 million square feet in 2022, it is expected to 1.5 times. That is around 380 million square foot, and this includes the residential, office, industrial, and real estate retail buildings. So this all shows the kind of potential that BIPV has in Tamil Nadu. So I think Tamil Nadu in itself could become a kind of hub for BIPV in India. Now coming on to what could be the challenges for BIPV in Tamil Nadu. So first and foremost is the lack of awareness. So this is what we are trying to solve right now, creating awareness. So we have had discussions with different stakeholders. We had discussions with real estate developers. Most of them were not aware. Very recently, we had a meeting in Madhya Pradesh where a lot of local real estate developers were there, who were working in and across MP. So most of them were not aware what BIPV is, but when we tried to explain it to them, they found it interesting, but they said, we want to know more. We want to know what kind of cost it would impact and what kind of savings we could get from BIPV installations. Then obviously the higher initial costs are there, but of course it is a dual purpose kind of thing. So you're replacing your building element with BIPV. So you are saving some cost, the actual glass, putting BIPV panels, and then you are generating electricity from those panels, which you are not doing in the case of when you are having just glass. Then there are technical barriers as to standardized design and local adaptation of BIPV that is missing right now, which is also one of the purposes of this particular event. Then there are regulatory gaps. We don't have a very fixed or a specific BIPV framework for India or for any state right now. And then the supply chain constraints are there. This again, this event is trying to solve a little bit. Now, we'll go to some case studies in India and overseas and then see what can we learn from them for BIPV implementation in Tamil Nadu. So there are some case studies in India. This is one of the earliest BIPV, large-scale BIPV installations in India, one of the flagship BIPV projects. So this is in Mumbai. It's a large BIPV system, as you can see, 863 kilowatt peak. And what they have done is they have installed panels, solar panels on all the facades. So not just north, south, but in fact, south, north, east, west, all the facades. So this is an example of, see, for example, in Tamil Nadu, Chennai and Coimbatore, you have a lot of these high rises. So there's a lot of scope for such kind of application in Tamil Nadu.
Facility here now. Converts data.
Okay, that is great. Okay, great. Great to know. Then you see this case of Vijayawada railway station. So this is the first BIPV powered railway station in India. Now we have a few more in North India, but this is the first one. So what they have done is on, I think, 4 platforms in the railway station, they have removed the GI sheets and they have directly installed the panels over it, making it a BIPV because they have replaced the building element and have installed solar panels on it. So this is a 130 kilowatt peak installation over 4 platforms. Now in Tamil Nadu, you have more than 500 railway stations. So then you can again imagine what kind of scope could have if you start to solarize these railway stations, not using rooftop, but using BIPV. So because if you do rooftop, then you still have to have the GI sheet. In some cases, they first retender the GI sheet because these GI sheets are old. They put new GI sheets and then over that they put these panels. But if you want to do BIPV, just remove the old GI sheets and put panels directly. And now we have applications where, as Abhinav was mentioning, these are leak proof and also there will be no problem of water seepage and all. So it will be a leak proof installation. Then again, this is a recent one. This is India's first renewable energy museum, which has been launched in Kolkata. So this is the kind of, say, a flagship initiative which kind of helps create awareness. So something of this sort, maybe in some of the prominent locations in Chennai, could grab a lot of attraction, a lot of eyeballs, and take the interest of BIPV to probably another level. Now we'll take a few learnings from some overseas installations. So this is a building in Australia. So this they call as Australia's first building to generate its own electricity on site. So what if you see the pictures here, you see that they have installed solar panels on the north and clear gazing on the south. And they have used thin film panels. So in these applications overseas, you will see that multiple module applications have been used. So for example, these are thin film panels. Then this you see, this is an application in Switzerland. Here they have used organic panels. These are diamond shaped panels. These are custom made panels for this purpose. And they have covered more than 14,000 square feet area here. So this again becomes a kind of, say, a thing which can grab a lot of attraction and eyeballs, something which could become a kind of a role model for BIPV application in the state also. This is another interesting application. This is the world's largest BIPV. This is staggering 120 megawatt BIPV at a single location. So this is a ceramic manufacturing facility in China. So what they've done is on 11 rooftops where they had the those sheets, GI sheets and asbestos sheets, they removed it and just put solar panels over it, covered the entire manufacturing facility with the solar panels, and they have now resulted in 120 megawatt of installation. This again, you see the kind of square foot area covered, more than 71 lakh square foot has been covered using these installations. So this again is a great example for having BIPV in the industrial space in Tamil Nadu. This is an application in Singapore. This is primarily for your business centers, and also this is again is a business center where they have used amorphous silicon PV glass modules, 125 kilowatt over, you see, 27,000 square feet. This is another interesting application. This is a church in Canada. It's a very old church, 50 years old. So there was some renovation going on in that church, and what they have done is they have installed flat and curved panels. You see these are the panels you see on the top and on those pillars. These are all panels. So this again is a good example of how retrofitting is also a good option for BIPV. It's not just meant for the new buildings. It can also be done on the old buildings. and in a place like church for that matter. Now, the next two slides are actually locations where we got the opportunity to visit because of course, the support of GIZ. So this is a senior care center in a place called Ticino in Switzerland. So if you see whatever gray you are seeing in that picture is all solar panels, wherever you see. So barring the windows, everything else is a solar panel. So this is a very interesting case because the design of this particular system had to consider shadows from the urban surroundings, shadow from the roof overhang itself, and shadow from the building itself, because it's, you see the shape of the building. So some parts of the building there's shade of because of the other parts of the building. So all those kind of design considerations were needed in that. Yeah, so you see these are monocrystalline light gray panels. And there's another interesting fact about this installation. There are points where the generation is the maximum, then there are points where the generation is the minimum in this overall system, and the difference is 2 times. So the point where it generates the lowest, that is say X, and the point which generates the maximum, it is 2X. So that kind of makes it a very interesting application. This again is another installation in same location, Ticino in Switzerland. This is a university campus. And you see they have installed 18 kilowatt peak over 1900 square feet. Now this again is interesting because they wanted to do a rooftop solar installation. But over the period and because of new regulations that came in the EU, they then went for a BIPV installation. So it took a lot of time to complete this installation, but it looks very beautiful. And if you are not told that these are solar panels, you will never be able to make it out that these are actually solar panels. So these are white colored PV luvers and they actually move. These are dynamic panels, so they move along the day based on the sun's motion. Now, what can we learn from all these applications from India as well as abroad? So in the Europe, as I mentioned, there are policies like the EPBD, which mandates kind of decarbonization of the entire building stock by 2050. So that is kind of helping more and more application in the Europe. Then in the US, you have an investment tax credit system. That is, if you install a BIP or for that matter, rooftop also, you are eligible to get 30% subsidies on your income tax, overall income tax. So that could be something very interesting in India also. Then next is a case from South Korea. So the Seoul metropolitan government, they had at one point of time launched a BIPV incentive scheme where they offered to cover 80% of the overall system cost itself. It was a process where developers had to apply and only the shortlisted ones were supposed to be given this kind of incentive, but it was a huge incentive. You can see 80%. Then these all systems also show us that it is very important to be flexible to regulatory changes because in the case, this particular case, as I mentioned, it started with a rooftop system, but then because of the regulatory changes and all, they decided we should go to BIPV for a long-term thing. Then having a diverse team is very, very important for any BIPV application. So at the start of the project itself, you need to have a good stakeholder ecosystem for that project. You need to have developers, you need to have architects, the consultants, the utilities together. Then only at early stage, you can start planning for a good BIPV installation. Then obviously the focus has to be on developing very innovative solutions that can provide you long-term sustainability. So some of the best practices also from all these applications that we have seen is importance of early integration of design. That is very important so that because BIPV in some cases may not be very easy as compared to say rooftop installation. So for example, in this particular case, you see it's a lot of complexity here. So it's important that you do it, integrate it in early into the design. That will be help. You select the right kind of materials, which is something we are trying to do right now in India, giving a lot of options. Then policy support, as you have seen, is very important. For example, see the case of Europe, case of US, case of South Korea. You see the policy support kind of drove the adoption of BIP. And then the last point, as I already mentioned, stakeholder engagement. So you need to for a BIP installation to be done, the number of stakeholders required is very high. It's much higher than what you get for a rooftop. If a rooftop, you just ask your EPC, go and install on my roof. It's very simple. But BIP, you need to have multiple stakeholders. So that kind of engagement is very important. Creating awareness between all these stakeholders is also very important. So we need to have stakeholder discussions for capacity building and increasing awareness, which we are doing right now here. And the key, what could be the key takeaways for Tamil Nadu is to first and foremost could be develop localized solution using the learnings that we had from the global best practices, the Indian best practices, and then to adopt it into Tamil Nadu's own market and climatic conditions, create a robust ecosystem, as I mentioned, the entire ecosystem of all the stakeholders, that is very important. Then the promotion of BIPV under the PM Surya scheme, that is very important because it is there in the PM Surya scheme, but the awareness is not there. I have spoken to few of my friends who are about to buy a new flat which is under construction. They got interested, but they had no clue how to go about it. So the question was, I want to do a BIPV on my balcony, but how do I go about it? To whom should I contact? So that is a question which needs to be answered fairly quickly. And then what is also important is that we launch high visibility projects which could become kind of iconic buildings in, say, iconic building in the heart of Chennai or maybe in Coimbatore, which kind of in itself creates awareness about BIPV, and it could help the adoption, further adoption of BIPV and scaling up of BIPV. That is all from my side. Thank you. Yes.
Yeah, a couple of questions. One is, you said, I mean, there will be a difference because all of them will not be facing the sun.
Yes.
Putting it in all the panels.
Yes.
It'll be quite a difference. So many of the panels are not utilized to the whole.
Yes.
And how do you clean those panels also? And third thing you said is it'll be 9 rupees. So is that a workable solution?
Yeah. So see, for example, in one of the first images that I showed was the CTRS data center they have installed on the roofs. So obviously the generation will be higher on the sides which face towards the south or say southeast or southwest, may not be as high on the other direction. But you also have to consider that you have replaced your building element. So for example, when you are constructing a new building, okay, you don't install the traditional glass, but you install solar panels. So it will cost you delta extra, some extra amount, but this particular solar panel will generate electricity for you. May not be as high as the other sides, may not be as high as a rooftop, but then this is the additional benefit that it is providing. So you have, when you compare the cost of BIPV, you have to mindful that BIPV is dual application, it is dual benefit. For instance, rooftop is just solar generation. There is no other benefit per se. But BIPV is also a building element, and then there is solar generation. So we have to consider both factors, and then only we should compare costs. And I think yes. Yes. So
I don't know who cleans
that will be similar to the similar rooftop installations which have been done across India. So in many of the stations across the country, and I think in MP and I think in some stations Delhi also, they have done rooftops. So they have an agency which weekly or say bi-weekly they put some arrangements to clean up balance. So similar can be replicated for BIPV at railway stations. But yes, that is an important factor because in places say like Delhi where there's a lot of dust, and even place like Chennai with a lot of humidity, you need to regularly kind of clean your panels. So I think yeah, it's an important factor to consider, but that should be a part of the overall when you do the design of it.
So it's important to understand that these BIPV modules are construction materials. So if it's made out of glass, it just has the same cleaning requirements as any glass that would be facade mounted.
Next, then we get from that, and it's all we still have time.
Yeah. Thank you, Mr. Shantaram. So we have an online someone join, Mr. Data More. So can connect them.
Good morning. Can you hear me?
Mr. Data.
Can you hear me?
Yeah.
Okay, perfect. So thank you for the invitation. So I listened the first or the last speaker, and yeah, I'm very impressed what you're doing there in China. It's early in the morning here in Europe. Yeah, I try to go fast through my presentation because it's only 50 minutes, if I'm not mistaken. And yeah, try to share my screen and hope it's working now in the presenter mode. Just a second. So can you confirm that you can see my starting screen?
Yeah, Doc. Mr. Data.
Okay, perfect. So I go straight into my presentation. It's a kind of technical presentation about BIPV as a building material. And first, let me introduce a little bit myself because I'm in the BIPV business since 2002, and they realized about 1,800 BIPV projects from very small balconies to big railway stations. And the interesting thing is that I did it as at the beginning of my career as a client, then most of my time as a producer, and now as an engineering officer, my company called Aconsol. And so I see the BIPV process and the BIPV business from different aspects, different perspectives. And what I'm doing now with Aconsol is, on one hand, I make a project business. I do development and also trainings. I give trainings. Let's say that what we are doing today is also kind of training and bring know-how to the auditorium. And when I speak about projects, I always say, and I've seen that Mr. Roy said also, one of his points was that he said we should really start with BIPV at the very early beginning. So what I do normally is I have a simulation tool for BIPV, and this is one of the first point for clients when they have a kind of decision-making process, because they need to know what is the output of different areas on the building. Otherwise, they can't decide if it makes sense to install PV or BIPV. And then it goes into detail engineering if the decision is done. I make tender support during the implementation and also monitoring inside. And these are some of the examples which I realized over the last 20 years. So from big glass roofs to facade systems. A lot of these projects are done in Switzerland. There's a big market in Switzerland. Traditionally, because in Switzerland they have a lot of mountains, less area where they can build solar parks. So they really need to go into the buildings. So it's one of the reasons why we have a good environment in Switzerland. My second field is business development. So I develop products, new concepts, or even old production lines with the know-how behind, and trainings on different levels. So I skill architects, engineers, do it also on academic level. And for example, UK, you have this kind of CPT seminar, so architects need to develop and educate themselves, otherwise they lose the license. So what are the key measures in India or over the world? What my experience was that you need cooperation, and that the cooperation needs to be between the architects, because they are normally the first players in the game who start with the engineer. You need the industry who is able to produce all this stuff which you try to put on the buildings. And finally, one very important player is the owner, because the owner pays for all of this what we are designing. And later on, I will go a little bit on this topic about the pricing, because sometimes BIPV is quite expensive, especially when it goes into very special designed panels, colored panels, different sizes and shapes and so on, maybe banded panels. And yes, and the owner needs to know what, on one hand, what is the output and what are the costs. But this needs to be in a very tight cooperation between these main stakeholders or players. You need to educate. Mr. Roy already mentioned, if somebody likes to, for example, an owner likes to install a BIPV installation, but nobody knows how to do it. So where should you start? And one point is really to educate architects and engineers that they can go with this idea to their clients. From my perspective, certification is a very big issue. I will show you later on some slides about the standards here in Europe and what you need to do if you go with this glass product into buildings, to envelopes. And also the same is regulation. And during my trip, end of last year, beginning of December last year, somebody said, we need to develop the right ecosystem in India. And this is really big challenge and also the main thing to do. And yeah, also with presentations today or with meetings we have today, I think you can develop the right ecosystem in here. So what are the showstoppers? If you have, for example, the wrong expectations, so I need to really state that there is a big difference between PV and BIPV. Both are producing electric energy, but from the design process, from the pricing, from the needs, for example, color solutions and so on, there are a really big difference. And you know, in my presentation, within these 15 minutes, I can't get into all of these topics, but later on I try to handle 3 of these topics in short time, and yeah, point out a little bit what could be the wrong expectation. And you need a really adapted strategy between PV and BIPV. So this is all the reason why we are sitting together today to find out what could be the right strategy. One point is also incentive. So my personal experience is it's fine if you can initiate something with incentives, but it should be never a kind of long-term perspective, because otherwise people are not innovative. If they see, okay, we get everything subsidized, so they need no innovation. So at the beginning, fine, it's good to make some reference projects, but not on the long-term perspective. We have a lot of initiatives here in Europe where you can see the early beginning, there was really boom in the industry, not in BIPV. It was, for example, in Spain, they had a regulation for standard PV. It lasts only 2 years, and after 2 years, it fell down to 0 because they had no more incentives to give to the individual installers. So I give you now these 3 brief inputs which I picked out of a couple of topics which you need to consider when you do BIPV. So first is about cells, second about glass, and then finally pricing. And if we speak about solar cells, there was a huge development over the last years. So when I started in 2005, so these 2 cell sizes were the standard, so 5-inch and M0. We had some cells with 4-inch, but it was really, at that time, it was kind of outdated. Nowadays, all the BIPV producers are producing in this range. You see there is quite small difference from 158 millimeter to 166. But even if you consider you produce a bigger panel out of this size, you really need to start at the early beginning with the right solar cells. Otherwise, you start designing and then maybe the building size change or the windows change, then you have to change also the cell size if you really make to customized PV panels. And the standard module producer, and I think also most of the producers in India, they're using M10 and 12 cells. What they are doing, they're cut it in half pieces, M12 maybe in 3 pieces, or they quarter it. So there's, for example, one BIPV company in Europe, they use the M12 cells and make 4 pieces out of it. So that means you come back to the size of let's say 20 years back. And the reason, or let's say one of the benefit doing this is when you go, for example, into semi-transparent PV panels. So I will show you something about semi-transparent and also colored solutions and try to explain what is important using these different cells, sizes, and different standards. So in semi-transparent solutions, you can see here, this is a 4-inch cell. So this is really a small cell. It's 125 by 125 millimeter. And I don't know if you can imagine it, but here you see different distances between the solar cells. So this is not rocket science, but the aim of the architect was to draw a kind of pattern in the envelope. And this is easier to do with smaller cells. If you consider the cell is 4 times bigger, then it's not so easy to make this kind of pattern in the PV panel. There is another one in Spain, capital Madrid, where they replaced the existing panel with these PV panels. And you see also, the smaller the solar cells are, easier it is to draw these lines. Another project here in Austria, so they used it as a kind of second skin wall, and also kind of fading out pattern here in the middle. There are less solar cells instead of top, bottom, and the smaller the cells are, the easier it is to create such pattern. Yeah, last project, the semi-transparent solution, is a project in Kazakhstan, the capital Astana, where they produce the kind of chest pattern, and also same like before, the smaller the cells, easier to make this pattern. When we come to colored solar cells, we have even the same say types of solar cells, but what we have to consider also, that you have this kind of tapes where you interconnect the solar cells. And the next slide you see is a project from 2008. It was an energy supplier, and their aim was, they said, okay, we are an energy supplier. We want to show that we are producing electric energy on our own facade. So they made a really sparkling, at that time, let's say a standard solar cell, polycrystalline solar cell. But what you can see also, the interconnections, they are very visible. And nowadays, when you go into PV facade, they are looking more like this. So this is, the middle here is a wooden structure, and the top here between the windows, these are PV panels. And in that case, you need to hide your interconnections. Otherwise, they will be very reflective. You could see them, and then it's obviously a PV panel. And some of the architects, they don't like to see that it's a PV panel. So you need to make some measures how to cover this shiny tapes, let's say. Another project from Switzerland with a reddish color, and the PV cells are also the stripes, the connectors of the cells are decked black color, painted. Same with golden panel. So there are a lot of developments here in Europe, how to color PV panels. And this is a solution where a golden color is printed on the surface of the glass. This is a project with thin film, copper indium selenide, Germany. What you can see here is the reason why I choose this type of project. They have only standardized measurement, and in between the facade company, they replace, or they make the fill it with the other material, which could be kind of aluminum bond or something like that. So let me come to the topic of the glass. This is a project in Austria, which I made pictures a couple of years ago. And yeah, it's a nice installation in a shopping center. And you see one of the panel is broken. So the front glass is broken, and it looks like, yeah, it's falling down because the front glass is not stable anymore. There on the back side, there is no glass. It's only a foil, and it's not stable enough. So it's really dangerous. You can see here, this building, 2 panels are already missing. And yeah, in the meantime, they replaced, or they demolished the whole facade, and the PV panels are away. A similar situation here in the project in Germany. See, there is a nice PV overhanging area with glass panels, but there is an area which is missing. So they used the wrong material. The lamination material was not stable enough, so both glasses were broken, and one of these pieces fell down. You see, could be around 10, 15 kilo. So it's really dangerous. And I always try to mention that when we use kind of electric material and turn it into a building material, we really need to consider that it needs to have other functions, not only electricity production. It's also should be a stable building product. And finally, some things about pricing. So I've found out, I don't know if it's true, but there is a Chinese website. They are listed around 160 PV panel producers in India. Maybe you can correct me, but this is really a huge amount. And I picked out only one of them, so it's Tata, and on the internet I found pricing about 13 rupees per watt. So I always try to convert it also in euro to see if it's the right uh, um, currency, and if I made a mistake. And when I was on my trip to India, somebody told me that if you use bricks, I don't know if it's true, but it was around 19 rupee per square meter for one square meter bricks, only the material, it's not installed. And if you try to compare these both, you see PV panel, a standard PV panel is quite higher price than a normal brick. So I don't know if I made a mistake. The only thing what I like to express with this calculation is to say, okay, when we go into BIPV, our competitor is not a standard PV installation on the roof. It's the facade or a glass roof or a balcony or whatever. And so this is something what we should consider. And I don't know the glass prices in India, but this is also what Mr. Roy mentioned before. When you compare a standard glass facade with a PV glass facade, you can deduct the cost which are already there for the glass, and then you can start your calculation. One thing, and this is really a very extreme example, it's a very big size 3 by 4 meter semi-transparent cell panel, triple insulated glass unit, and one piece is around 1.5 kilowatt, and it was at that time around 110,000 rupees per square meter. So in euro it was 1,200. So this is really, as an extreme example, I made it one time in my career, so I don't know if anybody else will do it in the future. But what I like to say with that is that we have a kind of standard solution and we have extreme examples, and in the reality we have this kind of individual standards, and we should find in every project where we are placed and how is the pricing and where we get the project done. And I'm 100% sure if you build the right environment in India and don't need to import it from Europe, that you could have great success with BIPV solutions in India. So I hope I was in time with 50 minutes, and I'm here also for some questions if there are, and I have to leave honestly in half an hour because I've some fire burning test today, so also a very important topic in BIPV. So I can stay with you another half an hour, but yeah, thank you for listening.
Thank you, Dieter. And we have questions. Ma'am, you can ask.
Good morning, rather early morning to you. I'm an architect by profession. My name is Sweta. One interesting documentation perspective I would like to hear from you is how much is the heat offset, whether it has been documented, because when we are replacing a building material, say brick in India, it also prevents the heat entering into the building. So my curiosity would be to understand what will be the heat offset that I can convince my clients with. And the second question would be, in the larger perspective of climate change, what will be the contribution of these glass solar panels in creating urban heat island effect? Thank you.
Yeah, thank you. Very interesting questions coming more and more in the last days. The first one, heat reduction in the building. So you have to consider, let's say, two different installation types. One could be a ventilated facade system, which is very popular here in Europe, which means you have your wall, make it insulating. You have a kind of thermal break and a ventilation. And then you have your external cladding, which could be a PV panel. And then you reduce your impact to the building because of this cavity. You could get out the heat. And the second installation would be a IG unit, an insulated glass unit, where you could let's say, the amount of the solar cell in the PV panel will reduce the impact into the building, because you have, let's say, three factors when we speak about radiation or physics. One, the sun shines on the material, you have a reflection, you have a transmission, and you have absorption. And if you put solar panels or solar cells in a solar panel, glass panel, then you can reduce the direct transmission by the amount of solar cell. It reduces also your let's say, your light which comes into the building, so it could get darker. But this is a kind of trade-off which you should find in individual projects. And there are also a lot of let's say, scientific papers where they made measurement about it. So it's called the G value, if you like to search for it. And the other one, the heat island effect. There are also some research papers out of that. When we say we can't reduce energy, because it's not possible to produce energy, we can't only convert energy. And if we say you have a PV panel, sun shines on it, and we put out, let's say, 15% of the solar energy which comes on the panel. So that means we use this energy in terms of electric energy. So it means the heat island effect should be lower than instead of having, let's say, a normal glass or a glass which get heated up and sucks no energy out in terms of electric energy. But again, I think there are a lot of scientific papers out there which you could investigate.
Hi, I'm architect Vijay. When it comes to BIPV, we understand we sandwich the circuit boards or the solar cell modules between glass or a glass with polymer material, these sort of materials. I would like to know what would be the life expectancy of the sandwiched or the cells inside this sandwiched surface. And next question would be, if at all we are going for a polymer backing instead of a glass, what would be a life expectancy of this?
I know one of the installation, it's I think 40 years ago, one of the first installation in Germany, which is still running. And BIPV honestly is quite, except of this one project, quite a young discipline. But most of the producers, so I can't give you an exact number. So is it 40 years? Is it 50 years? But what I can say is there are a lot of producers who give a guarantee about 20 years. And they give normally it's not a product guarantee. So it's a power guarantee. So for example, if you buy the material today with 100 watt peak installed capacity, the guarantee the next 10 years you will have 90% and the next 20 years 80% out of this initially installed power. And I think they wouldn't do it if they don't know that the material is long lasting. So for example, if the interlayer starts getting yellow, then the performance drops dramatically. So this is what I, when I started 2005 in my old company, so the oldest installations are 20 years old, and what I know, there are no problems with delaminations or whatever. And the second question about polymers, I didn't really understand what you mean with polymers. So you talk about different lamination materials, or because in the industry at the moment there are more or less 4 to 5 different lamination materials. So some of the producers use EVA foil, others PVB, PUE, and I know one producer who use a silicone, and the silicone is let's say, the most suitable for a solar cell, because it's really, let's say, very stressless embedded, but the production process is quite high because it's handmade. You need to fill the cavity between the two glass sheets with the silicone. You need to store it, and it needs cure, let's say. But this would be one of the best materials for PV panels.
Teacher, this is Shiva. So allow me to add some more clarity to the questions asked by our architect friend. So to give you more clarity, perhaps you are talking about laminated glass. Yes, the product warranty will be around 10 years for a laminated glass. The interlayers that we use inside could be EVA or PVB, and the product or performance warranty will be around 20 to 25 years. So the common interlayers that we have is EVA and PVB, and delamination warranty could also be around 10 years. So I hope I've answered your question. Thanks.
Any other questions?
See, I'm Babu, architect. See, the question is, when I'm changing to the BIPV material for the roofing, what will be the weight increase or decrease in the roofing material?
I don't know if I understand it right. What is the change of the weight, you said? The weight, yeah. There is a very, let's say, easy calculation because glass, the weight of glass is 2.5 kilograms per millimeter per square meter. And so a normal PV panel has around 3 millimeter front glass, and depends on of the producer if they use also a back glass. So it's 2 times 6 millimeter. The foil has also a certain weight, but it's not as dramatic as the glass. So if you say 6 millimeter multiplied with 2.5, it's around 13 to 15 kilo square meter weight for a standard PV panel. If you go for a roofing material, and depends, is it a let's say a roof tile which makes your watertight roof, or is it a glass roof with insulated glass chamber? Then you have to calculate the glass thickness according to your loads. So here in Austria, for example, we have a lot of snow loads. Sometimes you have to calculate the load for people who walk on the glass for maintenance, and then you increase your glass thickness according to this calculation. And yeah, it could go up to, let's say, to 50, 60 kilo if the static calculation needs a thicker glass. I don't know if I answered your question in the right way.
Thank you, Mr. Dieter. Considering time, I would request if anyone has any questions, can write emails to madraschamber@madraschamber.in. So we pass it on to our Mr. Dieter to get the answers. So before we get into panel discussions, thank you, Mr. Dieter, for the wonderful session. And thank you so much. Yep. Before we get into the panel discussion, we would request this mementos. I would request Ms. Bala to come and give a memento to Mr. Abhinav Jain. Mr. Abhinav, can you please? Ms. Bala is missing. Or maybe I can ask Mr. Martin to please come and. Thank you, Mr. Abhinav, for the wonderful remarks. Mr. Martin, please stay back and request Mr. Shantanu to come on. Thank you, Mr. Shantanu, for the wonderful session. Yeah, we'll move to the panel discussion now. So let them, put it in. Suresh, names change.
Call இப்படி நீங்க கூட படிங்க நீங்க மைக்ல
Take care as our next panel discussion followed by Q&A. Can we make BIPV a standard part of building construction? I would request Mr. Kotari, Managing Director, Conserve Consultants, to come on stage. He is our moderator. Yep. Mr. Daniel, request Mr. Daniel to join as one of the panelists. Mr. Shantanu Roy, Mr. Vijay Krishna, AC member, Indian Institute of Architecture, Chennai chapter. Mr. Durganand Balswar, Senior Advisor, UNP. Thank you, sir. Thanks everyone for joining. So I would request Mr. Kotari to start.
Thank you very much. A very good morning. And BIPV has been a very fascinating subject for all of us, and including me. I've been watching the development of BIPV for a very long time. It's got its own challenges, but I think the time has come to grab it and sort it out. So the panel discussion today is how can we make BIPV a standard part of building construction? So that's the question for the panel. And I'm happy to have a very, very varied cross-section of experts here. So what we are going to do quickly is that we will have each of the panel members give a small introduction of themselves and then talk 2 minutes about their opinions and thoughts on BIPV. And after that, we'll follow it up with a series of questions. For me, BIPV has been a dream whenever we talk or conceive of putting up any building. Whenever I talk to any architects or any developers, the first thing when they are conceiving of a project is that can we put some building integrated photovoltaic on some facade or on some roof or on some windows. It's always been a great desire and a great dream. But once we get into the specifics of what would be the power generation, what would be the cost, what would be the lighting that will be diffused through the PV, what is the ROI, the return on investment on the BIPV, the entire desire starts fizzling down. So it's important for all our panelists here to help us navigate these challenges, decode BIPV, so that it becomes an integral part of building construction. We'll start with Mr. Architect Vijay Krishna. I mean, if you could introduce yourself and then 2 minutes on your thoughts on BIPV.
Hi everyone. I'm architect Vijay Krishna. I have an experience of 25 years in this field, and I represent IAA Chennai Center, which is a 108 years old organization, and I'm an EC member there. Okay, my perspective as an architect, I think most of my architects colleagues will not vary from this. Earlier, architects, we talk about, or the industry talk about FSI
floor space index in a small land, how much we would build, what could be a efficiency we will build, what is the space, how is the air movement being planned, and all those things. Now that the industry is moving towards sustainability and whatnot, another 5 6 years we will talk about carbon neutral. Maybe a client will come to us asking, I need a completely a net zero building or a net positive building and a carbon neutral building. How do we achieve this? I think we need to go in for something like this sort of systems, like BIPVs or any other renewable mode of integrations to offset this. And I think there is a famous saying, like, rather than inventing new energy form, try to deep dive into the existing renewable form to find a solution. So I think with this, I think this BIPV will be the, as an architect, we have a long way to go in this. So.
Hello, I'm Daniel Lipschitz. I'm an architect and urban designer by background. But since the end of last century, I ventured in what we then called a self-sufficient integrated utility system for the built environment, specifically on a level of volume. And with regard to BIPV, through the years, it has been very interesting to see in Europe this marketplace and how this practice of developing different designs, finding different ways of integrating photovoltaics in buildings as a building material. And I have been fortunate over the last 2 years, together with Mr. Abhinav Jain and others, to go on this adventure of how to introduce BIPV in the Indian context. It has been an adventure, good days, bad days, challenges, opportunities, and whatnot. And I think the most important is to understand that BIPV, or we like to call it solar architecture, active buildings, is a construction material. So the question, and that is very much in the Indian mindset, no offense, there's always a lot of talk about the cost sensitivity. But BIPV in all its different products, and it's not just the modules, there's a whole system behind it, and it also has to be seen as a building system. But essentially, it's a construction material. So the question whether a construction material is expensive or not, from the point of view of an architect, is not so relevant. If I am designing a high-end resort and I use a marble imported from Italy because the client wants that, is that expensive or not? The client wants it. Then you can say, yes, but let's say non-active construction materials don't have a return on investment. But that's not true. If I build this resort and hotel, it needs to have a certain iconic function, of luxury, of leisure and whatnot, kind of aspirational factors I want to build into my design. And that also has a return on investment, because if the architect and the client would just go for the cheapest option, that return on investment for that specific program of that specific building would not be there. So I invite during the panel discussion and the remainder of the day and the sort of subsequent thinking about BIPV to see it as a construction material that can help us to make buildings more sustainable. But from the architect's point of view, it is not required to understand all the deep technological and technical aspects or all the market and financial and economic aspects, just as an architect doesn't need to understand how a slab of marble is quarried from a quarry in Ferrara in Italy.
Thank you. Thank you, Mr. Daniel. This was the right context you have set for the talk, and I'm sure it'll be very interesting. Shantanu, we have heard you. Anything that you would like to say?
I think Daniel has covered most of it. So, I mean, for the introductory part, nothing much left, but I would say BIPV is one application which, like rooftop solar, can cover the entire spectrum of all the consumers. So you can have very small installations, the residential 1 kilowatt level installations for BIPV to multiple megawatts of BIPV, as we seen in the presentation, the 120 megawatt installation in China. So I think that is very important that BIPV, since it covers a lot of consumer segments, it is also important that we focus on it, because each consumer segment for BIPV proliferation would be very, very critical. And a little bit about my organization, which I missed during the presentation. So I work for an organization called CSTEP, which is Center for Study of Science, Technology and Policy. It's a technology-based think tank, which is based in Bangalore with an additional office in Noida, where I am based. So CSTEP works, I mean, our group at CSTEP basically works for the proliferation of mainly the distributed renewable energy applications, which includes rooftop solar and also BIPV. Thank you.
Thank you. I'm architect Durganand Valsava, research practice called the Artist Roots Collaborative. It is about 35 years now that we've in practice. I'm also a senior advisor with UNEP, the United Nations Environment Program. I think as far as BIPV is concerned, it's in its nascent stage, but has immense potential in three major contexts. One, that solar energy is probably the most ubiquitous form of energy that is available to us, and therefore needs to be harnessed innovatively. That's one part. The second, I think, with global warming and the SDG commitments, it's time that clean energy was given much more focus, and it may mean even from governmental policy and various levels that we need to relook at the role of BIPV. I've been part of the German Energiewende project, and I think most of the insights came from there. We've not really used BIPV in buildings that we've done, but in the Energiewende project, I think more than the technology, the aspirational aspect and the calibration of policy, I think was very important in this transformation. So one is, of course, looking at the technology itself, but I think the aspirational, and it may sound a little controversial, it is not. In India today, given the speculative land values today, that when we get into projects, I think the percentage of construction cost that adds by 2% or 3% looks so negligible. And that's something to consider. So even when we discuss 2% or 8% of increase in construction cost, if you look at the overall project cost with the just unbelievable land values that we're experiencing, I think it's well within it to take cost as that factor, because you have several other benefits in bringing in a clean energy. Yeah, thank you.
Thank you. Thank you very much. We'll straight away get into the questions. I would like to start with Mr. Daniel first. The objective of the panel is to how do we make BIPV a standard part of building construction? With your experience, how does the industry, the architect, the engineer, the owner start? How do we make a beginning? We heard someone mention that one has got to get into simulations and so on and so forth. Where do we start?
How much time would you like to take me for answering that? Because the super short version, medium short, or the full version?
Medium short.
Medium short, okay. So I think, again, coming back, so apart from BIPV materials, of course, we always talk about glass modules, but there's other potential materials as well, the non-glass models. So whether these are any insulated sheet facade claddings, any ceramic or composite facade cladding. So there's a whole range of BIPV materials that we can consider construction material. It's one part. The other part is, of course, BIPV has a paradigm shift, because here all of a sudden you have a material that you integrate in your building that is generating a commodity, electricity in this case. So the technical aspects of BIPV create a And this is about the engineering and design. It is about additional stakeholders that come into the design, construction, but also the O&M process, the operation and maintenance process. And architects, engineers, builders, they cannot do this. They also shouldn't do this. There are specialized entities that do this, also in the European context. So first of all, we have as you have facade installers, the subcontractors of main contractors that take care of the roofs, of the electricity, the HVAC and whatnot. We have the BIPV module installers. We are very lucky to have one here among us today, Mr. Shiva. So there is a new entity that comes into the mix. Another entity that has proven imperative in creating successful BIPV projects is the so-called BIPV consultant and project manager. I myself represent a Swiss company that has been the spin-off of the university in Switzerland that we could call sort of the global hotspot on BIPV development over the years. So they have 15 years plus experience and went as a university, as an institution, very much into the marketplace to manage and streamline this added level of complexity, whether it's from engineering and design, whether it's from the whole BIPV process ecosystem with all the different stakeholders. How do you manage this? How do you project manage this? So that's another entity that comes into play. So as I said, the paradigm shift here is about the fact that all of a sudden you have a building that generates a commodity rather than being a user of commodity. And then, of course, that also has implications for the, let's say, the business model or revenue model that actually nobody here in India yet talks about. So who actually is the owner of the system? Who sells the electricity? Is it going to be sold back to the grid? Is it for self-consumption and self-sufficiency of the building? So how do you calculate this? And it was asked, so what is the sort of the lifetime of the active part of a BIPV module? What is guaranteed? So 20, 25 years. What happens afterwards? Not much, because you have a construction material that generated a commodity and then it will stop to do so. So there's many added levels of complexity in the whole process that neither the builders and developers, so the commissioners, be they private, be they public, neither the architects and engineers, nor the end users of the building or the users of the building should be bothered with. So for successful BIPV projects, you need new entities that have the experience and know how to take care of this added level of complexity. Then I saw that there also was a question about how the Indian Institute of Architects, the Chennai chapter, could help this. So we already are working with your colleagues from the Northern chapter. From the Northern chapter, and what we will organize with them are so-called awareness events, but also courses and the development of tools and resources. And this is not for the young and upcoming architects. It's not for the architecture students. This is specifically targeted towards the decision makers in firms for two reasons. One, they are instrumental. So the architect sort of is the hinge in the system. And of course, the hinge needs to be unlocked for the whole So the decision makers in the firms, be it the partners, the associates, the owners, they need to be informed about BIPV for two reasons. One is that they can inform their clients that there is this possibility. And in an increasing context whereby both voluntarily but also mandated reduction emissions footprints, environmental footprints need to go to net zero. We already know that clients will come to architects or to engineers, can you do BIPV for us? And then, if you're an architect, you say, so what's that? You lost your client. So that's one reason. The other reason is as I said, so the architect can inform the potential clients about this possibility. So, as it's one Indian Institute of Architects, maybe we can discuss how to join with your colleagues from the NCR region. Sorry, last but not least, because it was in the question here, so what is the function of policy? Now, what we've seen in Switzerland is that the more the BIPV market was regulated, the more subsidies and incentives there were, the less BIPV projects were done. It's really, I don't have the image here, but like you can see the number of BIPV projects got incentives go up. So this is really a lesson that we have to bring into the Indian context. Another regulatory tool, which is to mandate that builders, developers have a certain percentage of their electricity production provisioned by BIPV, that could work. And you can, for instance, think about specific RPOs like renewable purchase obligations, etc., etc. So policy has a role to play, but let's not forget that BIPV is a construction material, and therefore the market has to be left free. Fear not will be mainstreamed in India. It is something that has to come from the market. We don't know yet because the market is not there yet.
Thank you, Mr. Daniel. As you were talking, half a dozen questions came to my mind, but we'll come back to that later. But one important thing is the association between IIA and the training and the awareness. Maybe would like to know a bit more about that. I would like to ask Architect Vijay Krishnan. You must have come across clients asking for BIPV. You must have had a desire to also put up some BIPV. What were the challenges? What were the difficulties you faced?
Okay, well, it's a very complex question. In fact, as the colleague said, I think BIPV in India is in a very nascent stage. I think we'll have around a dozen of building today, which been done with complete BIPV. Maybe other things would be just PV, photovoltaic panels. The complexity, or when a client come to us with a request of going for BIPV, first, see, we look at it on a general note. It is an electrical appliance. Do we have a trained person to install this first? I think education, see, be it a building material. Today, this replaces a building facade, a sky roof cover, an atrium cover, maybe windows, everything, but then this is completely wired. We need to have a complete education knowledge to be transferred to the applicator who will be able to do this. So we lack over there. Maybe the first drawback we find. The next would be on the costing front. In fact, be it a bare glass, a lamy glass today, e-coated glass. Maybe I have people from glass industry too. See, today we get some lamy glass at the rate of 1,500 to 2,000 rupees with a performance. But what is the cost of this BIPV? And what is the bare panel cost, and what is the installed cost? This is another big question. See, I've been discussing with a couple of people, couple of manufacturers, and I see a payback period of somewhere between 35 to 40 years. I'm not sure whether this is true or because very limited players are present today in the industry. See, one is the overall cost increase of the construction per square feet cost increase, be it 8% to 12%. But what is the exact panel replacement cost? So this becomes a next tricky question. And next comes, what is the life period of the product? See, all these product, I presume, or whatever data analysis which I went through, these are mostly based out of Europe. We have a very less concentration of BV panels in this tropical climate. I think Indian context or very similar to Indian climatic condition, we have a very limited sort of an installation. What is the uh, life period of this product? And next question comes, there are a lot of questions I have. See, what we have is, we call a glass installed building directly contributes towards the heating load or of the building. Now that when I bring in a semi-transparent or a translucent BIPV, and BIPV comes with a sandwiched, it has been sandwiched between two layers. The outer layer is a plain glass. I hope I'm right. The outer layer is a plain glass so that it allows more amount of sunlight to hit the circuits or the cells to generate more power. And we put the coated glass on the inside layer. What is the increase of heat load because of this? So the moment you cut down the heat gain coefficient or the U value at the outside itself, it's a different one. When you're allowing the heat to pass through the first layer of glass and come to the second layer, what is the heat gain inside the premises? And will that be compensated? See, one side we are producing power, other side we are equally contributing to the increase in heat load. Yes, climatic conditions like Europe, where we don't have so much of heat load, rather we will have some other like cooling load. There it contributes, but these things comes into picture. See, and next thing is we do not have a policy guideline straight. See, this is a electrical appliances put on a facade, and we need to have some amount of safety standards and installation guidelines being accepted, and the policymakers too need to accept this and regulate this. We do not have it currently. Maybe the next NPC, which is about to be rolled out, may come in with this sort of things. So when I summarize this, I have a technical constraint, I have a financial economical constraint, I have a manpower or installation constraint, and next thing is the energy one. Adding to the last part of it, we do not have I presume we do not have a manufacturing facility in India as of now. Whomever I was discussing, they say this gets imported from predominantly from Europe. So what is the embodied energy attached to it? So the carbon footprint once again increases into it. So these questions has to be addressed to make sure the BIPV has been brought part of the building and we start promoting it to move towards net zero or net positive.
Thank you, Architect Vijay. I think there are many questions and answers. It's very obvious, and I thank MCCI and the organizers to bring this, have this discussion today. I think it'll open up our minds into many other thoughts and ideas, and this has to continue. Just one thing, Vijay, is when you mentioned 35 years payback period, I could see Daniel sigh and go back.
I think you just set the context for the next event. I hope it's recorded, so we have the list, and that will be for the next event. But of course, the guarantee, the performance guarantee, has to exceed the payback time. Yeah, and it depends on the context and what type of project it is, whether this is on break even or there is a margin in there, etc., etc. But as I said, like, your questions are totally valid, and I think it is a next event or another event.
Thank you. I'll just quickly go to Shantanu. I think we have another maybe 10 minutes. Yeah. Yeah, sure.
I think his question shouldn't go, at least unaddressed. We may not be able to answer, but all of your questions were, if like, I come across this term. So my child is 5-year-old, and we told him the story of Gruffalo. That who is Gruffalo? Which animal it is? So everybody have an idea of Gruffalo, that it looks like this, it have these features, it have these things, but it may be a small, animal at the end of the day. So what the question all of you which you have asked, I think what we should do and we will do, that will make a FAQ, yeah, and put all these questions, give the answer and also the links to those answers, right? Like for your cost calculation, they had done very wonderful work. You have an Excel sheet, you just download it, see everything there, replacement cost, everything, and get your number. You may change your assumption and check it for your generation, for the heat analysis, because this is all well researched subject. One thing you said which is correct and which is not there is modules in India, because these modules are not what Indian manufacturers had target till now, because there was no market yet, but they have all the capacity. So most of the manufacturers said, you give me the order, I will give you the module. There's no problem me giving the module, but the thing is that order didn't exist. So this is my just brief address to you, but we will provide you all the info. Thank you. Thank you for allowing.
I think I'll just pick up the last points of what you mentioned about guidelines. Shantanu, anything that you would like to add on guidelines? Because I saw in your presentation one slide on guidelines. What are the guidelines? What are the standards? What are the codes that one can use? Thank you.
Okay, so with the support of GIZ, so C-STEP along with School of Planning and Architecture, and Daniel was the international expert for that assignment, we have developed those guidelines. So those guidelines, the major purpose is to guide all the stakeholders who are there in the entire ecosystem of BIPV. So that guidebook can be used by architects, can be used by BIPV practitioners, can be used by designers, can be used by policymakers. So there are chapters for each section. So you have a technical specification section, you have a section on system designing, what factors, what parameters should you consider. There's a section on installation, maintenance, and very importantly, fire safety, electrical safety, because this also involves working on heights. So these are some of the parameters that have been covered in the guidelines, so as to provide you the initial steps to each stakeholder who wants to go for a BIPV. It may not include the entire depth of technical designing and all, because it's a guideline. It provides you the guiding steps to do it, and from there you can pick it up. So that is the purpose of the guidelines actually. So that is there, yeah, and I mean it's free to use. So please, I mean I would request everyone to please go through it, and if you have any comments, so we can maybe address that before the final version comes out, because it's under review with MNRE. And along with that, I think I'll add a few more. Is there any other question you want to ask? Yeah, so I think a few more points I think I would like to add regarding how scaling up of BIPV can happen. So we can broadly kind of divide BIPV into two segments. One is the residential segment and one is the larger segment, which is the primary, which would be the primary driver of BIPV. So for the second segment, it is the most important stakeholder becomes the real estate. Because if the real estate is kind of interested, is kind of aware of what BIPV is, BIPV can really take off. So suppose you have some of the big real estate developers fully interested in BIPV, and they take it up and they do actually install BIPV on big commercial establishments, in the malls, in commercial buildings, like we saw the CTRS data center. So that can obviously then create more interested in the other stakeholder, in the other developers also. So I think real estate developers is the most important stakeholder for large scale BIPV, and they have to be supported by the architects. So there could be a case when the architect proposes to the real estate developer that you should go for BIPV, and these are the benefits, these are the financial benefits, these are the technical benefits. And there could be cases when a real estate developer themselves ask the architect. So it can happen both ways. So very important that all the stakeholders have a clear knowledge about BIPV, it can take off. And coming on to the other segment, which is the residential segment. So I think since now it's a subsidized scheme, BIPV, under the PM Surya Ghar, but unfortunately there is no awareness. I don't know if there has been any installation under the PM Surya Ghar of BIPV. So that is a big question. I don't know, but I have spoken to people. We have been a part of a few consumer awareness campaigns for rooftop solar in MP. So we brought this topic to those people who had the money, also who had the affluence to go for rooftop solar, or for that matter BIP. Also, we asked them, suppose now some of them they had independent houses, but some of them they also had some flats, some apartments. So they asked us what to do. So we said this could be one option, and you may be surprised to know there's a video from MNRE on the PM Surya Ghar scheme which also mentions about BIPV. There's a small section on that video which talks about BIPV, that if you don't have a roof, but you have a, say, south-facing balcony or a window, you can still go for BIPV, but then the awareness is not there. So my point was, consumers are interested. There are few consumers who have the money, but they don't have independent roofs, or they may not want to use a roof. So their interest was, can we actually use, because they also have a lot of glass installation on the buildings, and in some cases these buildings are under construction, their apartments are under construction, so there is a potential of actually installing BIPV. So the interest is there. I mean, people to whom we have explained that this could be a potential application, interest has come, because they said, okay, then in that case our roof space also will be saved, because we'll be using a existing building material. So that was a plus. But then again, it's very important to create this awareness, and then the government also on a central level and a state level, there's need to be a push, because there's a lot of push on the PM Surya scheme for rooftops, so it's doing well across the states. But then if you have included BIPV, there also needs a push for BIPV. Now coming on to a slightly different topic on this, BIPV versus a rooftop. So rooftop, even the construction of a rooftop solar is fairly simple. You have a roof, you go and install it. But BIPV, it could be on, say, 15th floor, the facade of 20th floor of a building. So the challenges, there are multiple challenges also. You need to be sure of safety at working at height. Then there is electrical work also, which is required to be done at height. Fire safety, because these spaces could be, ventilation is very important. So on a policy front, we had a Surya Mitra scheme. It's already there to train people to go and do small installations, primarily rooftop solar. So as per the, I think, government numbers, there are 50,000 trained Surya Mitras in India who can do primarily the rooftop solar installation. So it's also important that something on these lines could be done for BIPV, because the BIPV installation is very, very different from a rooftop installation. A lot of higher skill is needed to do a BIPV installation versus a rooftop installation. So I think that again is a very important factor to consider.
Yeah. I would like to address two things here. Like, first of all, and no offense, Shantanu, but rooftop solar really has very little, if not nothing, to do with BIPV. For many reasons that we don't have to discuss here now. So, and also, of course, the schemes for rooftop solar, they cannot be replicated for BIPV, because in many cases, the end user of BIPV will not be the person that lives in the house, or but more importantly is to understand about the Indian context with regard to the marketplaces for BIPV. So we differentiate largely between three marketplaces, and there are many other marketplaces, etc., etc. So the first marketplace is the four big metro areas where you have the super high-rise building with glass facades, curtain walls, and whatnot. And these buildings, you will find them in Chicago, in Melbourne, in Sao Paulo, in Noida, in Mumbai. There's nothing special about these buildings. There's no vernacular, and there is a very high repetition of the same panel, whether it's active or not. So this market typically is interesting. As Abhinav said, there are interested potential manufacturers of BIPV modules, but then we talk about Vari, we talk about Saint-Gobain, we talk about Adani, Tata, these type of manufacturers. So this market, where there's a very high replicability, where there is no specific architectural or vernacular specific needs, there's no need for customization. There we will see probably like a lot of traction happening for, let's call it, India Inc. Is that interesting for architects or not? I don't know. The big developers, so I'm not familiar with how it is here in Tamil Nadu or in Chennai, but if we talk about NCR region, so you have your Hero Real Estate, DLF, Adani Real Estate. These developers typically are the owners of the land. They will retain the property of the volumes that they build. They will have the in-house design and engineering department, the in-house main contracting and subcontracting firms, the structural contracts with the construction material suppliers, as well as their in-house R&D units on building technology and construction material technology. So basically, it's interesting because when you look in Europe, those would all be different stakeholders. Here in India, it's one company, one corporation that has it all. And vis-a-vis, for instance, a company like Vari, or Saint-Gobain, they can move this market very fast. That's the first market. The second market, and forgive me the simplicity, is the rest of India. So this would be typically your mid to high rise. It would be your high-end sector, etc., etc. So here you need a completely different approach. It's a very different marketplace where the architect is leading. So here you need a very high diversity of different products that can be brought to bear. It is regional specific, it is vernacular specific, etc., etc. So here you need a distributed networks of BIPV ecosystems. And then the third marketplace, which isn't talked a lot about, is retrofitting. The existing volumes and also the upcoming volumes to be built is 70% of urban stock still to be built. Of course, through time, there's a cyclical requirement for retrofitting where BIPV also can be applied. So there's this largely three markets with a lot of sub-markets. It's important to understand about these different marketplaces.
Thank you.
Yeah, just one last point. I think there's some really interesting work which has started on BIPV in India. We have representatives from Quadrant Solar here who are doing excellent in-roof solutions for BIPV. So I think they have installed, I think, as big as 3.5 megawatt, somewhere in 3.25. Yeah. Yes. So I think in Odisha, right? Yeah. And we also have Shiva, whose organization called Goggles Energy. They have done 44 kilowatt peak BIPV installation right here in Chennai. It's in Anna Nagar, right? It's an office building called IMI, which is there. Yeah.
Thank you. I'll quickly go to Mr. Durgana. What is the role UNEP plays to make BIPV popular in India and Tamil Nadu? And what do you see the future? How do you see the future of BIPV?
Here, I think because BIPV is in the nascent stage, so it's still work in progress. But maybe since we brought up the issue of both possibilities and challenges, I would quickly raise a few of those. So from a point of view of possibilities, both from SDG and the urban heat island, which has been questioned often, possibilities is that with global warming, the need for cooling, air conditioning is definitely going to increase dramatically, which means that clean energy and renewable energy becomes the core. And therefore, solar, BIPV and all will come center stage at some point. Because at the present, whether we're using coal or other forms of generation, no one is paying the price for global warming. So in the context of not paying the price for pollution, we're doing a calculation. So there's an unfair advantage that other forms through certain subsidies are getting. So that's one part at the governmental or policy level. I don't think there's too much time there or luxury of time now, given the way the climate is changing. So I think at some point it will come into the overall picture. So one has to look at the overall larger picture so UNEP has a program which is looking at neighborhoods. And besides the building, I think neighborhood design becomes a very important consideration. So it's not the building itself because the building itself as a generator of energy is an amazing concept. It's almost self-reliant then. So that's where BIPV would play a strong role, so that's the possibility. In terms of challenges, of course, when we go down to the ground, and we are practicing architects, and whether one is discussing with a patron or a developer, or it could be BMW or who of those, at the ground level, the resistance largely springs from, I don't think it's as financial, I can be corrected. Resistance springs from the fact that we need to see an ecosystem that's working. So an ecosystem will mean that a developer doesn't feel trapped by a monopoly single producer. He wants multiple producers. The other will mean that there is a very strong capacity building of including awareness and skill of each stage of that ecosystem to bring a certain comfort to adopt a new system. Because when there's a new system, I think the assurance given by, and I'm saying this a little lightly, I know it's not as light as many times today, the developer or the architect is asking, what is the lifespan of the manufacturer rather than the product? So I think that's also something which is of very high consideration, because in the end, the Indian market is working on, when we say socio-economic, it is the socio which is as strong as the economic. So the social aspect, the idea of trust, the idea of the manufacturer being there much longer and being able to absorb the kind of risks involved in a new technology. I think those are also running in the mind of large projects. So that's one of the, and I think the earlier presentations actually covered most of, there was not much to, they've covered it and we've written down the points. I think today was a learning experience for us as well, because this is a new product. So I think if that FAQ can really look at this entire operation, maintenance, and I think there are many, as I said, as research projects which are showing how it could be recycled. So it's not as if 20-year was a, but that the recycling gives new options for investment. It's not a waste in that sense. So while it goes out of the boundaries of what the industry sees, I think bringing a transdisciplinary team, like for instance, in neighborhood, this UHIE or urban heat island, there is, if it's combined with like what Orville Consulting is doing on nature-based solutions, and we've tried that. So the microclimate itself is also absorbing what is seen as the heat that the panel is generating. There are early stages, and I hope that proceeds, early changes where the heat generated, let's say in hotel, now this is just speculative, but I think it's part of a research. The heat generated by these panels through what was discussed as the layering, or it's called the chimney effect, can actually go into a kitchen. So instead of throwing it back into the environment, it can be captured for the kitchen. I think the Paris metros come close to exploring that. So we need to, what BIPV is doing is pushing us as architects to reimagine that entire ecosystem, and not see it just as a substitute for a solar panel, or it's a paradigm shift as it was discussed. Thank you.
Thank you very much. So Loganathan, do we have time or how are we on time? 5 moments. Yeah. See, all the way we're talking about a proposed development. What happens to the existing projects, existing development? Do we have anything? Say, I've been reading something called BAPV, building attached photovoltaic. Maybe this may also lead to a larger amount of sustainability cars.
I think on existing buildings, so blind walls and whatnot, nobody wants to see regular PV panels attached. But as I said, like there's a third market, which is retrofitting. So there are specific products and specific engineering solutions for retrofitting existing building and also make them active buildings in their own right.
Thank you very much. Thank you. I think we've had a very, very interesting panel discussion, opened up a lot of questions. And I think it's laid the trend, I think, for MCCI and the organizers of how to take this forward. I think we need more training. We need more awareness session. We need the manufacturers also to come in to give confidence to all of us on how this whole thing works. I have been lucky to be a part of Control S. I am aware of the entire solar wraparound that has happened in the building at Navi Mumbai. I am also involved, and I think we should also get Seabros, who is the owner of this hotel, Mr. Whalen, who is the CEO of Seabros. They are talking about BIPV in some way or the other. So we should get them involved. We should get the developers involved. We should get the marketplaces, as you have segmented, all of them involved. And thank you very much. I think I'll open up for more questions from the audience. Yeah, I think a lot of hands going up. Mr. Loganathan, you have to handle the time now.
One more questions than answers.
I'll just quickly finish it because I have 3 questions, all interrelated to each other. So we are looking at optimization of the solar cell, but is there an optimization on the supporting components? Because there is always a contradiction of AC to DC conversion, which is a big challenge in convincing clients on the per square feet utilization value of any space. This is from a residential perspective because they are already in tight space. And the second, considering the lifespan of these panels to be a generation ranging between 35 to 60 years, what do we have as a backup plan for after their lifespan? Do we have a proper waste management in place? Because right now we are facing the brunt of waste management where we have consumed plastic. So are we not loading the upcoming generation in end of the lifespan of these products? These are hazardous waste. So do we have a waste management in place as a country, as a global center point where India is going to be a carbon neutral? So where is the waste management in this carbon neutral perspective? That's it.
I think there were 2 questions.
Oh, yeah. I mean, the third question was the waste management protocols.
Right. Yeah, they connect.
When you are focusing so many residences, already the government at the policy level is struggling for waste management.
Sure.
So now we are adding to the hazardous waste management. So what is the policy level, practices?
You throw in a 30 to 60 year time horizon, which BIPV wasn't even conceived 30 years ago. So take that in mind. But for your first question, so if we are willing to let go of looking at BIPV just as another means to add, X gigawatt to the Indian overall renewable installed capacity, but we start looking at BIPV for where it was originally conceived for, that is to make buildings active, self-consuming, and sufficient in their energy provision, then why should we actually invert the electricity? We can just use the DC, and for direct applications in the Indian context, you would think about cooling. So a lot of the cooling load could be provisioned by using the DC generated by BIPV modules. So that's one, and there of course are other applications. Think about BIPV to EV charging, etc., etc. So, and that is why the idea of neighborhoods is very interesting, because if we have connected BIPV volumes in smart grids, then also we can optimize the direct usage on neighborhood level or clustered BIPV buildings, and I believe that is the way to go. The problem is that in Europe, it is the niche of a niche market, whereas here in India, even if it doesn't go mainstream, even like if 2% of this 309 gigawatt that is seen somewhere on the horizon, even if 2% of that comes true, we will still be able to do something. That's the answer to your first question. On your second question, it's really interesting because this is exactly more or less in the European context, in the R&D, innovation on the institutional level, it's being looked at. So I can share with you some studies and also some actual research projects that are going on that are applied in upcoming projects about the end of life of the BIPV system. So it's not just the modules, it's the whole system, based on 2 things. One is to look at the proprietary model for BIPV systems to become BIPV as a service, where the supplier of the system retains the ownership, becomes basically the seller of the electricity provided during its lifetime. Here in India, I would say it's like an IPP, like a micro IPP, and then also is responsible for the end of life modular disassemblance and recycling and upcycling of its constituent components. So it's very interesting that you mentioned this, because this is sort of the state of the art where now is being looked at. So if we can exchange, yeah. So those are my answers.
Thank you. One more question and one more. That's about.
Yeah, I'm Arun Ribera. I'm representing Tamil Nadu Solar Energy Developer Association, as well as my own company, Contour Solar. There are a few more questions. Thing is, first is from my organization, we were focusing on BIPV during 2012 to 2015. We tied up with a few European partners, and we developed many solutions, closely worked with architects. A lot of things has happened, but till now, there are a lot of specific techno-commercial aspects not have been addressed. So off the table, I really want to discuss if you can support on that. We'd love to do that. And the second thing is, we can really, a lot of members in Tamil Nadu Solar Energy Developer Association are really interested on this. If there is any specific solutions are there, we are definitely ready to support. And on the Surya Gar, there is the DCR content is there. They spoke about the balcony, all of the things, but there is no. I don't see any specific mention on DCR content on BIPV. Can you?
That was the point that I was also making.
Yeah.
They have put it in the policy, but the implementation of it is something which is probably not started yet. So all the whatever rules are there for getting a subsidy under the residential rooftop are the same for.
But DCR content doesn't match any of the BIPV.
Yes, so that is where the problem is. That's why I said I don't know if there is a single installation of BIPV under the PMV.
There is no compliant fulfillment in that.
So that so we have a starting point that it is there in the scheme, but it's yet to take off. That was what I was trying to say.
Oh, thank you, sir.
Thank you very much. With this, shall we close?
Yeah.
But I see quite a few hands coming up. Maybe you could talk later to the panelists. Thank you very much. Thank you, Mr. Vijay, Daniel, Shantanu, and Durganand. I just want to leave one last thought, which Daniel mentioned. BIPV should be viewed as a building construction material. Just like how you use Italian marble. Does Italian marble have an ROI? Thank you.
Thank you, panelists. We have a speaker waiting overseas, so thought we conclude this session on can we make a BIPV standard part of building construction? We would like to take a moment to express our heartfelt thanks to our panelists. Thanks for the wonderful session. Yeah. It's a token of our appreciation, Auroville Consulting and MCCI to present you with a memento. I would request all the panelists to stay back in the stage for a minute. I would request Mr. Balakrishnan to come and give a memento. Thank you, panelists. And I would request to Mr. Balakrishnan to give a memento to Mr. Kochari. Sir, thank you, sir. Thanks for your time. Mr. Daniel, okay. Mr. Daniel, thanks for your time, Mr. Daniel, today. Mr. Vijay Krishna, thank you, sir. Thanks for your insightful session today. Yeah, Mr. Durkanand Pulsavar. Thank you, sir. Thank you. Thank you, Mr. Shantanu. Thanks for the wonderful session. Thank you, Mr. Balakrishnan. So I would request Mr. Hans to join the session. Thanks, Hans, Mr. Hans, for joining the session. And thank you. We join in the morning 9:30, and hope you are enjoying the session.
So far, very good. Thank you very much.
Okay. Thank you. Thanks for joining, Mr. Hans. So over to you, Mr. Hans. Please give us an overview of BIPV manufacturing value chain. We would love to hear that.
So
So-
here's Mr. Mann's profile. Please carry on, Mr. Hans.
Thank you very much for inviting me, and I followed all mornings the session, and I'm glad we are getting slightly and slowly to the point. It's a building material, and every other building material has no return at all. And the other thing which is already mentioned was it's a very complex thing, and today I'm coming more from the manufacturing side, and my presentation is geared for manufacturing, less than what Dieter mentioned on the consulting side. And our job typically is to make it simple and take the complexity out for the customer, and not say, oh, it's complex, I'm sorry. We should say it's easy, we do it, no worries about it. So, and the other thing what I heard was we are not getting really the benefit. Everybody looks at the price and the cost, but really, 1/3 of the global emissions come from real estate and from construction. And 60% of the global energy consumption is used in urban areas. So under that umbrella, I would like to start, and I'm glad that I'm invited, and also I hope you can see the presentation already on the screen. So today we are showing to our audience at the Chamber of Commerce, the Madras Chamber. I hope there are a lot of people in the room who are interested in manufacturing and maybe setting up businesses, and there are entrepreneurs around who like to see which opportunities there are out to manufacture BIPV. Very brief, I go into the market opportunity. I go into briefly in the product because Dieter has already explained more than enough about the product itself. Where's a BIPV manufacturer, if you consider to go into that business, located in the whole value chain, and a path forward to go to gigawatt scale and summarizing it. So we already heard Europe is the strongest marketplace right now with a most mature area, giving you a feeling. Typical project sizes are right now between 500 and 2,000 square meters. Very many EU programs were already referred going on. Another thing is going on. China is now slowly but surely also going into the BIPV market, mostly in a field what's more referred to the panelists BAPV field, adapted, not fully integrated. In India, I don't believe it's true to say there's no manufacturer. There are already some companies out who do first products and have done projects. And South and North America are first players on the market. So you see, it's a good time to start, even under that shield, made in India, made for the world. So we have for the product different marketplaces. Daniel also talked about it. I'm just mirroring it. The product needs to fit for different climate zones. India is a large country. And it needs to be a resilient product because we go in a building which typical lifetimes are at least 25 years. So it has to withstand temperature, weather condition, and all concerns. Two major markets, new constructions. Somebody already said it. There's a tremendous growth in new constructions. And net zero buildings is nowadays, from my point of view, a must, and looking to it. It's a 309 gigawatt opportunity over the next 20 years. And just to give you a context to it, the largest Indian manufacturer today has roughly a capacity of 13 gigawatts. So there's enough space for entrepreneurs, for manufacturers around to support that growth. What do we need to understand from a product standpoint as a manufacturer? And we must underline it more and more. It's a building material. It's a construction material, which needs to meet national building codes, standards of buildings, on top of all electrical norms, what the PV industry is doing. And therefore, then we meet all the global demand. Here, roughly, the complexity we are dealing in a very short slide. The product a manufacturer is offering needs to seamlessly integrate into a building envelope. It must be superior for our eyes. And it must be cost efficient. As every product, everything in the world, it needs to have at one point a reason why it's in the market. And on top, you need to deal with different mounting systems, etc. The challenge for a manufacturer is, and I showed it just a little bit on the dimensions, and don't say that is enough. You go from very small size modules to medium size modules and big size modules, and Dieter even showed some going up to 4 meters by 3 meters. So you can do pretty much everything. And that is something you like to gear up slowly but surely as a manufacturer. What you have on top of it, you want to maximize the power of your available space. So even trying to use triangular panels or other things. The ribbons should be invisible. You want to have a uniform color. The colors need to match. And a lot of times you want to have a very stable appearance on the colors. And on top, it must be a very, very safe product. The least we want to have is that based on a not right product, a fire on a large building, and have a disaster as we have seen with other products in the world, which would certainly push back very hard on our industry. I took that slide in today because I'm hoping that I'm addressing also to some entrepreneurs and manufacturers. We should not only see it as a product itself, as a glass solar module. We also need to think in a system and integrate to the facade builders. But the real opportunity for a manufacturer is also, we can look from two ecosystem sides. So I would call that more a platform. Your panel can be a platform for solutions provider. You can merge into digital tools in the future, smart grid integration. We already know and learn from Europe that the grids are getting unstable. Our buildings can help support stability through storage, through data management, through energy management. Somebody said earlier, paradigm change. The paradigm change on a 30,000 foot level for renewables is certainly, in the past we had large power plants and they followed the demand. Now we have not always solar and wind and renewables available. So we need to also adjust our power consumption to the available electricity. So that is from my side and from my point of view, the big paradigm change. The demand needs to follow the available energy. And as the buildings are one of the largest consumers. Then you can go in service models as a business with data management, storage, charging, etc. And the lady just 15 minutes ago said recycling, that's also something we can do in the future, circular economy. The manufacturer himself find him in a very difficult spot. Everybody is looking at the manufacturer and say, hey, give me the solution. But really, and I took the manufacturer a little bit away from the sales team because they are typically dealing in the very beginning with the owners, developers, with governments, with architects and designers to get these projects kicked off. But end of the day, the purchase order, the warranty, the relationship needs to be also on the contractors, on the general contractors, on the facade builder who actually installs it. So we do a lot of work upfront before we even get and receive a order for a project. So that's why that ecosystem is so important, because the manufacturer himself cannot really deal with all the aspects of a facade, of a construction site, and he should not do it in the future. Cost was always addressed today already. So we need industrial scale manufacturing. Today's landscape looks very much like tailor-made, handmade, semi-automated manufacturing. Some numbers run around from whatever, 150 euros a square meter to 1,000. It's not very a transparent market either on the safety side, on the certification side, on the fire safety side. So this industry needs to mature, and India has a really good chance to also leapfrog and go already to a higher level. But still, you need to have a starting point. Some people said, oh, where do I get some manufacturing? Where do I get these panels? And here would be some recommendation from my side. Start with a pilot line, because that is inexpensive, highly flexible, and you can do everything and anything. Low capex, you can deliver small volume projects. I would put it out like 20, 80 modules a day, and you get already started. This leads automatically with a growing demand, and that is driven by how much market do you develop and how fast does the market grow. Then you go in a tailor-made, customizing, automated size, and then you are talking already in the 10 or 100,000 square meter range. And the market will then show how much standardization will happen or how much customization will happen. And then you will decide as a manufacturer, do you focus on 4, 6, 8 dimensions, which the market is requesting, or is the market and the automation degree and the manufacturing so far advanced that you can go in a mass customization, which from my point of view is the highest level you can reach as a BIPV or PV manufacturer, or even takes a B away and say you are integrated PV manufacturer by any means. This is how a automation's fully automated line for kind of a serial manufacturer looks like. It's to the highest standards, doesn't require any more many people, but it allows you to manufacture on an extreme high level of degree of quality, of repeatability, and I'm addressing here more the manufacturing people in the room, not the architects. But what you want to have on a building is one looks like the other, and you do not want to have any issues later on quality claims, etc. That already brings me to my summary. Once more, it's a building material, it's a construction material. A manufacturer is also depending on a good local ecosystem, supply chain of cells, of glass, educated owners, developers, and architects, and so on. And these partnerships are extremely important to grow that whole industry. And keep in mind, it's a 300 gigawatt market opportunity, and it deserves effort. How will it develop? It will develop now in stages. The market will demand in the beginning everything and anything, and you have a lot of innovative architects out who would like to show their capabilities and abilities. The volume will grow, local supply chains will develop, and that is how the industrial scale will be reached. It will be an evolution of the manufacturing from literally handmade modules to mass customization. And feel free to reach out anytime to me. I can support you. In my last venture, I built up a BIPV manufacturing line, the one you have just seen, in roughly 1.5 years, and produced quite a number of modules a day already within 1.5, 2 years. So reach out to me. I'm here to help. I'm supporting you, and that hopefully gives now some food for the discussion coming up. Thank you very much.
Thanks. Thank you, Mr. Han.
You're welcome.
Questions? Questions and can ask, can directly write to him or. Thank you, Mr. Han.
You're welcome.
Thank you so much for your session today. So we get into our next part. This BIPV manufacturing value chain in Tamil Nadu. We would request Mr. Surya Narayana Rao. He is our moderator today. Yeah. Tamil Nadu. Thanks for joining, Mr. Gaurav. Let's come on stage. Dr. K. Srinivas Reddy, Professor, IIT Chennai. Says outside. Venkat Rajagopalan, Vice President Operations, Vikram Solar. Thank you, Mr. Venkat, for joining. Mr. Arvind Jain, Chief Operating Officer, Ornate Solar. Mr. Arvind Jain. Yo, yes, here. Thanks. Yeah, it's here. I just call him. Professor William.
We're waiting for the fourth panelist, the professor, to join. He's just outside. Good afternoon. I think that was a very intense. Yeah, Professor, please join us. Please join us. Careful, careful. Back. We had a very intense first discussion on how to make BIPV as a building material. And I did hear, we did hear a number of points on why and it's not being implemented right now. We heard about somebody not the architect was Mr. Vijay Krishna is here. Yeah, he's not here. Mr. Vijay Krishna had put forth a lot of questions on that, and to answer all that, we have here our team now. We have the policymakers. He was talking about what policies are required to be done, what manufacturers need to do, about what are the technological developments that need to take place. There were a lot of queries on that. And here on this panel, we have all the four people here who can, I hope, throw light onto this and also share their opinion and knowledge. Welcome once again. I'm Suryanarayan Rao, been in the power transmission and distribution for the last 45 years, at a stage where we share our experiences, whether you like it or not, we do that. That's how we move forward. And with me, I now request the panelists, starting from that side, you could just maybe a 2 minutes on yourself, on your company.
Good afternoon, everybody. I'm Arvind Jain, Chief Operating Officer, Ornate Solar. So Ornate Solar was established in 2014 with a vision to provide sustainable future for India. So with that, we have been working hard since 2014 for developing solar created models, which can be actually good for all the industries. Back in 2017-18, just before COVID, we actually saw few installation in Germany where the panels were made as a roofing material. So from there, we got an idea that it can be actually made, and from there, our R&D work started. So we are the only company, a solar company in India who has been DSIR approved lab, Department of Science and Industrial Research Organization. So from there, we actually developed in-roof, which is integrated roof, where we have made solar panel as a primary roof. And during development of that, the first installation we did was for 1600 rupees per square feet. Now we are doing at 500 rupees per square feet, because within years of our experience, we have been able to reduce that cost because we are able to reduce on the cost of engineering, continuous engineering, because when you make anything a product, then actually you realize that it can be a sustainable model for everybody. So that's why we have been doing a lot of research work into that. And we are presently working on battery energy storage solution on a large scale basis right now. And this is what Ornate Solar is all about. Thank you so much.
Mr. Dev.
Well, thank you, everyone, for inviting us, especially MCCI and Mr. Rao for the conversation yesterday. My name is Gaurav. I'm Associate Vice President at Guidance. Guidance is the investment promotion arm of the government of Tamil Nadu. We are within the industries department. So to your question of we having all answers, I'm not the right person to begin with. And I think someone from energy or electricity or now the more and more I learn about BIPV, I think even more you need CMDA and DTCP also to be involved. I think those guys will need to be in the conversation to kind of come up with solutions and all of that. But the coming back to what we do, we are an investment promotion agency, so we facilitate large scale investments into Tamil Nadu, and I can talk about more as to what we have done in the recent past in terms of solar, PV value chain and so forth. Thanks.
Thank you. Thank you.
Good afternoon. Yes, good afternoon, everyone. My name is Venkat. I head operations for Vikram Solar's PV plant here in Oragadam. We have a 1.3 gigawatt facility. To answer a very specific point Mr. Dayanand brought up in the previous panel, is the manufacturer going to be around more than the panel? Yes, we have been around for 20 years. Last month, we completed 20 years in the Indian solar industry. And Vikram is one of the pioneers in the PV stage. And so it's a bankable company, bankable organization. We have about 4.5 gigawatt of PV manufacturing capacity today, expanding to another 6 gigawatt modules and 3 gigawatt cells in Gangaikondan in Tirunelveli by end of this year. So we are doing a lot of things in PV, pushing the boundaries. Like to share my thoughts on BIPV space in India on this panel. Thank you.
Good afternoon to all of you. So I am Srinivas Reddy from IIT Madras. I'm a professor in Department of Mechanical Engineering. So as you know that basically I'm from academia. IIT Madras is involved in various aspects of energy broadly, of course, across the spectrum of energy, and in particular solar and BIPV also we are working. Mainly our approach is a 4D approach: design, development, demonstration, and deployment. Of course, we also have a good association with industries, mainly for commercialization. There are several technologies have gone to the field, and especially our R&D activities mainly on PV and thermal and by PV systems, and some of our industrial associates as well as spin-offs from our academic collaboration have already started activities in this area. I think there's a lot of scope for R&D aspects. Thank you very much.
Like I said, this panel is really good to give you all the possible solutions possible that take you forward and guide us together in forming policies and moving forward. Now, let's start with obviously the policymakers are the first in the line. So we need to go with the policymakers. I don't know how many of you, every time we cross Sri Perumbudur, Oragadam, we get into the traffic jams there. Hundreds of buses, full of people, workers moving around, staff moving around. On one side, it's a traffic jam, but on the other side, you see it's the employment that has been generated by the investment that has come into the state. This is primarily done with the help of the investment guidance, and it's an amazing job. 30 years back, when I used to go into Sri Perumbudur, nobody would come. The taxi driver wouldn't come. He'll say, sir, anga pona, in Tamil, I'm switching on. The taxi driver would say, sir, anga pona, bayama irukku, sir, adichiruvaanga. Today, that place is really booming. Oragadam is booming. Coimbatore is booming. Tirupur is booming. Thanks again, once again, to the guidance center. And with that, we take forward on to BIPV. BIPV is nothing but a subsidiary of solar. Solar is overall the parent energy process. So solar itself in Tamil Nadu, we all know, has shaped up. How it has shaped up, maybe we can hear directly from Mr. Gaurav, how it is done up. That will give us some basis on how BIPV also can move. We had all the same challenges when solar started. I think challenges were no different. BIPV is a subsidiary of solar. It's one segment of it. So once we understand how the industry itself functions and how the policymakers make the changes, let's hear from the horse's mouth, they say. Let's hear from him. The horse's mouth is actually in a betting race. They get it from the horse's mouth so that they know whether the horse will win or not. So that's where you are. Over to them.
Spot, but I can give a little bit of macro. I mean, I think everybody knows this in the room, but the macro picture here is, our value chain for specifically for solar is, reliant on few countries, right? And we are kind of importing wafers, ingots, even today, with a very high majority from few countries in the Northern Asia. Now, that's not a good thing to begin with, right? I mean, if as a country, as a state, we need to, kind of bring that supply chain, localize in country, and do innovation, then we need to have some of those production systems in our country. So with that, let's say macro proposition or macro challenge that you have, and COVID was again an interesting example how supply chain got immensely disrupted. So, if we kind of mapped out who could be possible, companies and systems that we can target, and what we have done in the last 2-3 years, you would see that we have been able to get companies who are not dependent upon supply chain from Northern Asia, and so examples here is companies like First Solar, whose supply chain is independent of the inputs that you get from Northern Asia, right? So they use cadmium as one of the inputs to do your solar PV manufacturing, and that's an important investment that we have been able to get, and they are up and running, and suppose they are also supplying to various markets, both domestically and internationally. I understand First Solar is also into the BIPV segment, but I'm not too sure if they're doing it from here. But as a company, I mean, if they see a demand and if there is opportunity, I'm sure they will be able to contribute there as well. So that's one, right? So how are you able to build supply chain where supply chain itself is dependent upon few countries? So First Solar is a good example of how both center and state government is able to kind of capitalize and bring them to India. And then we have also in the panel Vikram Solar and Tata Power, both of whom we have been able to kind of bring into Tamil Nadu and see how best they can grow here. Now you talked about Sri Perumbudur and Oragadam cluster, which is booming, bustling, and full of traffic and so forth. Now we want to create that kind of scenario in other parts of the state. Right. So Vikram Solar is also our partner in that journey. Who wants to do that in south of Tamil Nadu in Gangaikondan in Tirunelveli, and Honorable CM kind of laid the foundation few months back, I think last month, there in person. So that's one good move. And second is Tata Power. Their biggest facility, 4.3 gigawatt of solar and cell module facility in one roof anywhere in India is in Gangaikondan and Tirunelveli, and 80% of the workforce is female. So you see huge shift in terms of nowhere in India you have in one shed such a big facility, right? So and that ecosystem is also being developed. So you have Chennai, you have Gangaikondan, which have able to move at least in cell and module. Of course, we will have to do much more to go towards ingots and wafers. So that's one ecosystem that we have been able to help and develop. Also, another company that we have been facilitating is Swellet. I think they're in Coimbatore, and they're also coming into the ecosystem. So overall, in Chennai, in Coimbatore, in southern parts of Tamil Nadu, you're able to see growth happening in terms of the supply side, the manufacturing side of it. Of course, a lot more needs to be done to ensure that it's fully integrated and we are able to bring some of these innovation. Maybe I'll stop here, and if you have any, okay. So that's one, right? And two is how do you capitalize on all of these investments and value chain being created to do BIPV, right? So that's another important value chain. So it's not just what I understand, it's solar panels. So it's also what people talked about of different materials. You have Saint Gobain, which is already here, one of their biggest facilities. One small anecdote on Saint Gobain. Saint Gobain, in their 230 or 250 years of existence, never ever had a board meeting outside of Paris, and the only board meeting that they ever chose to do outside of Paris was in Sri Perumbudur in Chennai. And so that was a big achievement that they are able to think about Tamil Nadu and India as an important market. So companies like them could also be nudged to do BIPV. Again, I'm not privy to if they're already doing it from here. So that supply chain is already here. Also, power electronics is also an important component here. In electronics, as you know, we have been doing really very well, not only in iPhones or the mobile supply chain, but also on EMS player, where companies like Flextronics, Sanmina, BYD, Lakshya, Delta Electronics, which is an important player in the power electronics, is also have their major footprint here. So you have a footprint or a value chain in fuels. You have little bit of companies coming in glass. Saint Gobain, Corning, by the way, is also setting up their facility in Pillai uh, next to First Solar. So that value chain is also being created there. In power electronics, you have multiple EMS players and also other companies like Hitachi and so forth, setting up their manufacturing here and so forth. So across the value chain, I think we are trying to make efforts, and hopefully, given all the kind of complex challenges in adoption, if that can kind of get sorted, then I think you will have a good mix for both supply and demand here. I'll stop here and then take it up for more.
I think that gives a lot of confidence to us that we are on the right track. BIPV. For those who had apprehensions, we should be able to do that. Maybe a little time. Mr. Gaurav, just to take on one more point, there are a lot of issues with Tamil Nadu in solar. I mean, rooftop-wise, to be very frank, the rooftop solar in Tamil Nadu is much lesser accepted than outside. The number of people who have taken it. I know it's not in your terrain. Off the record, can we ask you about how would you suggest to us to go forward on these challenges that solar itself is facing, so that BIPV may not face these ones? Off the record, I'm requesting you because you are in industry.
No. Thank you for that question. And I think one good thing that you see is that no more fossil fuel based power generation. New addition is being happening in TN. So let's say after 2019, at least as far as my knowledge goes, no more new addition based on non-renewable sources is taking place. So it's a good signal that the government and the department wants to move towards cleaner sources of power and adoption. So that's there. But also equally, and you are right that the generation in renewable energy is also weakening since 2019, and we took some efforts with energy department last year in January during our global investors meet, and tried to get some of these companies to come to Tamil Nadu and do power generation, both for wind and solar. So there is a kind of some efforts being taken there. But on your question of adoption, now I know there are policy challenges and regulatory issues there, but more and more we see at least industrial companies are willing to adopt primarily for two purposes. One is globally you see a lot of quote unquote carbon border taxes coming in. CBAM and UK will have their own and so forth. So they are, if you, as a state, if you want to promote exports, as of these companies, if they want to exports to, let's say, markets like EU or US or elsewhere, you need to cleaner forms of energy. Rooftop is one, but BIPV here can play an important role because then you can target some of these industries, and they already have, let's say, a goal to go towards cleaner and greener, and you are making a case here for BIPV, and hence they are your easy targets for adoption when compared to, let's say, residential communities and so forth. And so that is one opportunity where I see one could do, and now more and more CNI users are exiting your traditional grid, right? So they are exiting your grid. They're putting up their own forms of solar power generation because of exports and so forth. So here I see that industries could be a good target to start off some of this adoption compared to, let's say, residential and other urban centers which could have other challenges as well. Rooftop could be one of that. Many companies are doing. I know Daimler has their tracks fully installed with solar. I think their rooftop is so companies have an intrinsic a need to do it because their customers and all of that demands it, and so there I think you can easily nudge them towards that.
Thank you, Mr. Gaurav. I think that's a perspective we can take forward. It's obvious that the BIPV will have a few segments before it comes in. One is the immediate low-hanging, like the Vijayawada railway station and others, which are already there, and which can by itself per se develop a lot of get developed quickly. It's a part of the BIPV, and then we have the new existing buildings, and then the new proposed. So there'll be three segments which are coming in. I think one of the first one is the railway stations, and others can be taken up. For you, I'll take forward, Mr. Arvind. there were a lot of, in the previous panel discussions, the apprehensions were put forth that it's fine, but who will supply us? I mean, if you go to a builder, an architect, the first question they ask is, yes, I'm prepared to go for BIPV, but who's going to supply us? Who's going to give us the technology? Who's going to help us install it? And who's going to give us confidence on maintenance? From your side, can you throw some light on this being a manufacturer?
So BIPV in India should be treated as a different topic other than PV. Because the problem is that when you treat anything as PV, your taxes, duties and everything is according to that. So when you treat as a separate chapter a BIPV, then actually you can create government targets, you can create different taxes, you can create adoption. So till you don't take BIPV as a separate chapter, you cannot actually do it. So when we started this in-roof integration, so we faced the similar problem because of the cost and everything. So somebody believed in us on a picture that your roof will look like this. So when he actually, it was simple a paper, what we showed him ki your roof will look like this. And he told his architect, go convince him, I'll put it. And we went to the architect, we convinced him and it was through. So he gave me the price what I wanted. And that's why my in-roof integration started. Today, I have done 20 megawatt of in-roof installation across India. And these are all PB buildings. The height which I have, maximum height which I have done is 25 meters. Single shed at Assam. And you may know that Assam is a very tricky climatic weather where we have to do. So that was a difficult challenge. So how the entire ecosystem has to be created for BIPV. So I would suggest first government should set up a target for BIPV. Still there is no target. It is a PV target actually. Since if there is a BIPV target, then actually this will take air. Then a performance like incentive to actually put up the manufacturing lines for not only the PV panels but also the integration parts actually. If you see if you go for a colored system, there you require color glasses actually, colored glasses. Then you have attachments and you have encapsulants which has to be required. So different raw materials are required which has to be supported. In present situation, if I talk about, there should be relaxation on import duties. Actually, when there will be few installation, since I have done 2 lakh square feet, now I am having a confidence to actually pitch it into the market and go. I give my customer details to the customer and they are really happy. Few people still come, nahi, I need a POC. So I told, sir, 20 megawatt kar liya hai. I'm sorry, I'm speaking in Hindi. 20 megawatt I have done and 4 years I have been performing. So I don't need to bring you a POC. So another challenges is like everybody comes with a lot of questions. We are ready to answer those questions, but we have been performing in BIPV. So somebody has to believe that yes, BIPV can be done. So there are questions, there will be questions from consultant, there will be questions from many people that can be answered, but the belief has to come because since Roy sir were telling, so I was actually listening onto that we have been actually telling everybody this, but the belief is not coming from them. Okay, yes, I can go for BIP. Till that yes is not coming, then we are not going ahead. Then we need R&D grants also because a lot of it's on an early stage right now, BIPV. So if we do R&D grants to a lot of people in India, so we actually can create milestones in BIPV because India being a service giant can actually serve the globe parallelly. Then if you see presently, if you see, I would suggest that few projects, milestone projects should be done because since those milestone projects will lead others to take the call on BIPV. So when I went to JSPL for pitching the entire thing, it was like, aapne lagaya kahan hai? So where you have put up the installation. So we showed them the installation and we got the next order. We showed them the other installation, we got the next order. So when there will be installation, we will get the next order. If there are no installation, we will be keep on talking and there will be no work actually done on the grounds. So this is one. And here the government has to come that whatever public buildings are coming, those should be with BIPV, because they have that money to actually invest into that. They have to generate net zero buildings. Presently, what is happening? You are investing on grid, you are investing on everything, but you are not investing on a building which can actually generate the electricity round the clock. You have only roof to actually put up the solar panel. But why can't a wall be used as a solar panel? Why can't a battery energy system storage can be used? Whatever electricity is generated in daytime, the extra electricity can be stored, and that entire building can be a power generating unit for that same building. So you do not need transmission lines, you do not need it's just an concept. When the GIZ organized a trip to Germany for me, so when we went to Newtown, I was really amazed to see the entire concept. It has a thermal heating concept, it has a solar panel which is generating electricity. So when a building is being developed, it is a heart which has to be developed. You have to put lot of integration and bring in. So this would actually, if some installations government is helping, then actually this will really air the entire BIPV thing. And then some few last points which I would like to come on is some green financials and bank support should come into pictures, because whenever there are large BIPV installation happening, so customer is saying कि you bring the loan for me and then I can do it. Bank says कि भाई facade पे लगा रहे हो, किसी ने पत्थर मार दिया, मतलब anybody's hit the stone, it will break. So there is a lot of challenges we are facing, but we have to convince everybody कि when we did our first banking arrangement with SIDBI for this in-roof installation, they were really not convinced, because that has become a part of your PB building. They're saying if he does not pay me, I cannot take out his PB building. So that is another challenge, that when financing is done, he cannot take out the solar panel out of it. But we were able to convince our customer out of it कि when you take a loan, you do not get a loan on a roof sheet, but you get a loan on a solar panel. So that was the big thing which we were able to achieve. This was what a BIPV would actually take on a supply chain basis.
Thank you. I think you're quite passionate about it, and that was quite obvious. Appreciate that. Really, we need people like you to take forward BIPV. You were talking about new buildings and how it goes on. What would be your selling point, let's say, to an architect? The lady had a lot of questions today in the forum. That's right. She's an architect and she wants to convince somebody to go in for a BIPV building. Let's say she wants to convince madam to go in for a BIPV building. How would you sell it, man? Because they have a lot of queries on this now, which is the basic hurdle that we heard in the whole session before, right? From your point of view, you're the marketing person for your Ornate, and you're selling BIPVs. Can you tell us how would you go about it? I'm sorry if I put it in it, but I just thought
I'm in a very good situation right now, because if she is convinced, she will sell my product. If you're convinced with my idea, then you are selling my product, right? So how it comes about is generally we have learned from our experience. In last 4 years, what we have done is we first ask a person these are the concept which we have already done. Now for integrated roof, in roof, I don't require anything, because I can show you the installation. I have already done it. In Bangalore, I have done 45,000 square feet, 1.3 megawatt. I have done 2 lakh square feet, 3.25 megawatt. You can talk to my customer. You can go see the installation. I can show you the physics, what I have done behind it. People ask, it will leak. I will show you the physics. Physics does not leak. The system leaks, but physics does not leak. So if I have done my physics right, if I've done my workmanship right, it will not leak. So I can convince you, I can show you one video, I'll show you, and you will be convinced what I'm doing is right. Because I'm using a normal solar panel, and I am actually treating a structure around it to make it as a BIPV. So the BIPV is not only solar panel which we are selling. The BIPV is a structure. BIPV is entire concept which we have to sell. There was few questions from your side that How about the DC AC power system? That all is integrated inside. You cannot see you will not see a wire inside it. I will show you some photographs. You will be amazed and you will be ready to take my product.
I think what he's literally saying is seeing is believing. You have to go and see the installation. Yes, I agree with you. We take that and we'll move forward on. He's here, BIPV, and we have with us, we'll come to the professor last because that's where he has to tell us that whatever they said will be technologically obsolete by the time he's coming out of the new one. Let's hope he comes out with that. We'll come to him last to give us the shocks on that. Before that, we will move into Mr. Venkat. Mr. Venkat, you heard he's trying to sell it, and we had all the policy decisions. From the manufacturing point of view, what are your challenges that you're facing in this industry, and how are you going to go forward onto that? Yeah, Mr. Venkat, as you all know, he's from Vikram Solar, and he's the operations head for Vikram Solar.
From manufacturing standpoint, as somebody mentioned, today capacity of BIPV manufacturing in India, it's still nascent stage. So 2009, when I started solar, it's all about mind space, right? Today, there's 100, 200 people sitting here talking about BIPV. This has to happen more often. BIPV is something at the back of everybody's mind, not at the front. Even last year, till April last year, just a year back from now, PV manufacturing in India was considered nascent. In 2022, we had about 20 gigawatt of manufacturing. In 2024, we had 80 gigawatt of manufacturing. In just 2 years, the scale has gone tremendously. And why that has happened? Very specifically because of government policies supporting solar as an industry. The approved list of manufacturers and models. There's an ALMM policy by the central government, which was announced in 2019, which said every project in India has to use module made in India. So they kept pushing it out till they allowed the Indian manufacturing ecosystem to build up and then implemented it. At one point, people were saying it's just a policy the government's not going to implement, but there was a science behind it. They let capacity add up so that as a country, we are self-sufficient in manufacturing. When I implement this order, I need to have my customers be able to source modules from India. So that was the idea. Last April, it was implemented. And since then, manufacturing in PV has gone through the roof. Like Gaurav said, we still have work to do in the upstream business. Likewise, BIPV has to have a push from the government, bring it to people's in front of people that this is a technology whose time has come. Especially with all the work TN guidance TN has been doing. Every day I read in the papers about a new GCC being opened in Chennai. And all of these are glass facade buildings. There's a lot of opportunity to bring in BIPV right at the design stage. So more GCCs are going to come. I'm absolutely confident that there is, especially in a well-developed economy like Tamil Nadu, which is one of the top 2 in the nation, as industrialized as we have been in the past 70, 80 years of since independence, there is a lot of scope for BIPV to come to the forefront as we put more infrastructure in place, more buildings in place. So to support that, just like the Indian central government and state governments come with PV policies, Tamil Nadu has an EV policy. I think we have to come up with a formal BIPV policy. What the government expects the industry to scale up to, and then what the government can do. It has to go hand in hand. Again, this is not something which will happen overnight. It is a chicken and egg problem at this stage, right? Whether Vikram Solar can make BIPV, yes, we can. But at the point, what is the demand for it for us to go in? We are not worried about scale. Like I just told you, in another year or so, we'll be a 15 gigawatt PV manufacturer. So we can do scale. Indian companies can scale up. That is no longer a question. Where to scale up? What do we focus on? That will be the question. And number 2, again, I can sell a product, but every building is different. There is no one size fits all BIPV panel unless it's a normal PV panel. I can give you a 550 watt peak solar module today. It's a standard size we make. We make thousands every day. But when it comes to BIPV, homeowner thinks different from a warehouse owner, thinks different from a industry owner. Everybody wants their own aesthetics at the end of the day on the building. So there is no one size fits all policy. That will take some time to mature. So as you see in the morning, the PV cells, right? The cells have gone up in size from 4-inch. Today I can get a 12-inch wafer. That's 3 times the size. So it takes time for the industry to mature and in terms of technology to arrive at a certain point where we say, okay, this one size will fit 80% of buildings. And architects can also think now have a standardized BIPV product. I can already think of installing solar right at the design stage. They don't have to search for should I put this or this. That variation in product has also to be streamlined as we go forward. That challenge will solve itself once more people start accepting BIPV and thinking along those right at the building construction stage. Third point, which you mentioned about greenhouse effect, right? The whole intent of going solar or BIPV is to reduce greenhouse emissions, be more environment friendly. But Chennai or Tamil Nadu or India, we are more tropical. If I'm putting a glass facade full of electrical panels in the front, that definitely is going to add up to my heat index for the building. So I'm saving money long term by putting in solar and BIPV, but I'm expending more on keeping the building cool, especially now today. Yesterday was the hottest day of the season and we are still March 7th. I'm really worried about June and July this time. So those are things which we have to take into effect from an industry standpoint, from an implementation standpoint. I can build manufacturing, but this is something as industry solve this problem. So that is something I have to look at going forward. RPO, renewable purchase obligation. I think there's already some policies in place. Every new building has to have certain amount of power coming from PV. Maybe some of that can also be diverted as a PV/BIPV. So that's something which can come from the government, and CMDA regulations can enforce that. So all new buildings need a BIPV or a PV solution for their for being self-sufficient from the grid. So that's something which government can look at. And last one is the technology changeover. And again, coming back to the panel sizes, when I joined in 2009, one panel was 240 watt peak. Today, I can, in my own factory, make you a 700 watt peak panel. So let's say these panels are warranted for 10, 20 years, 25 years. Panels will last if made with good quality materials. Panels, I've seen panels made in 1982 performing more than 90% till today. That's about a 45-year time frame. If the materials are good, if the panel manufacturing process is good, the panel will last. Solar on a large scale is a install and forget it kind of technology. That's why it's so attractive. As long as you keep the panels clean, it'll perform. Dirt is a killer. So as long as you keep it clean, panels will perform. My question is, let's say I make a building today with a certain type of panel, and 5 years later, 5 of those panels go bad. Will that panel be replaced by likewise panel module? That's a challenge. That's something I see. And last one, a lot of awareness about solar is still one missing one point. Solar does not need heat. We need light. A solar module in Ladakh, high in altitude, it runs cooler. It performs better than a solar panel in Chennai where it's hot. So with all the infrastructure push that Guidance Tamil Nadu is bringing, there's a lot of dust accumulation, not in a not in a negative sense, but as a developing nation, there is huge push on infrastructure. We're building kilometers of roads every day. We're building buildings left, right, and center for our growing population. For a lot of different things, infrastructure push is happening. There's a lot of dust accumulation. So how do you keep the panels clean on a 25, 50-story building, right? That's something, as long as if you have dust covering the panels, they will underperform. So they have to be cleaned on a regular basis. That also has to be added into the cost of ownership of a BIPV system. So these are some of challenges I see going forward, but none of these are without solutions. We just have to cross that bridge and make it big, get it in people's mind space, and then cross that bridge.
Thank you, Venkat. I think that was good overall from the manufacturing point of view. We will now move on to Professor Professor would like to make a presentation? You can talk, right. Just to give you a perspective, IIT is doing a lot of work, like many other engineering institutions around in Tamil Nadu. Recently, you would have read that IIT got a grant of 8,000 crores, is it? That is for E-plane. They go to, just last week, they go to lift up ambulance straight from the traffic direct to the hospital. They have been involved in a number of innovative projects. I think the government of Tamil Nadu is working with them for sewage cleaning system, wherein the whole sewage can be cleaned with a robo. I think the government is working on that. The 3D printings they are doing, I think they can change technology for us. They can bring in new technology. Maybe what we hear, with all due respects, maybe become obsolete and we may have something new. Let's hear from Professor Srinivas Reddy what he has in mind.
Thank you very much. I think I'll add to this list. The Hyperloop is also another one. So in fact, yeah, so we are talking on BIPV. So as you know that, as you know that it's building integrated PV. Generally, when you integrate with a building, the major challenge is actually it requires four aspects. One is energy. The other one is illumination. Third one is functionality, structural stability, and of course, the third one is the life. When you compare with life of the PV against the life of the building, I think again obsolescence is another reason. Obsolescence, life of the system is also we have to look at. So how do we match these four aspects with the building structure, building or even built environment? So therefore, it's important to come up with a solution, not only energy, but also a structural element and also space conditioning. So if you look at nowadays, every building is without space conditioning, you cannot live actually. So, and again, it differs from weather conditions to, we have different climatic zones. How do we address this? But I think definitely at our academia is ready for having solutions for all the things, including cleaning, including power generation. And we are working one unique system. You know that we are developing a space conditioning system with BIPV, and it caters both the environments extreme, like he mentioned about Leh, Ladakh region where you have a minus 22 plus 20 temperature. And here we are talking about 40, 45 degrees Celsius. So now how do we cater this requirement? So we built a system, because I'm giving one example, but there's many such technologies are there. You can have a PCM panels backside of the BIPV, and whatever the heat which is absorbed is converted into heat, and which gives the space heating. Okay, but and that is in maybe Leh condition where you need to keep human comfort is about 25 degrees Celsius and 55 degree relative humidity, 55% relative humidity. So when you heat the PCM panels, what the heat absorbed by the PCM will give into the space. Whereas in Chennai climate, same PCM panel can also be used to give these cooling conditions. What you do is that you circulate chilled water inside the PCM panels. So we chill with the solar vapor absorption system, and that cold is circulated within the space so that you can maintain the cold conditions. Then hot water, warm water circulation in same PCM panels is a one innovative technology. But again, cleaning is another aspect. Stability, structural stability. We built a solar brick which converts solar energy into electrical and also gives the illumination as well as the space condition. It serves the three purposes: illumination, power generation, and it's a structural component. So it's a functional like any brick, a normal brick. It's a facade element, and also gives the illumination so that no need to you spend much energy on the lighting. So therefore, there are several technological innovations, but the major thing is I kind of three A's or four A's: accessibility, affordability, acceptability, and affordability. So these are important. Any system which you make it, it should be accessible, it should be available, acceptable, and of course affordable. So therefore, what I mean to say here is any solution which we develop should go into, as I mentioned, for the approach, it should go demonstration level. And then material accessibility, government policies, they definitely play an important role when we take it to the commercial level. So of course, there is a academia industry link is very important that can bridge the gap or bridge the solution so that we can make it more sustainable BIPV solution for any structural, any built environment. So therefore, we are there to give the solutions, but obsolescence, as I mentioned, that say the life of the panel against the life of the building. So we may have to go 4 to 5 times a change. See, we talk about average age of the building is 60 years. So the panel we can, and the technological innovations now like like phone. Every year we are getting new technology. So therefore, how do we match these two are important. Of course, I think with the help of academia as well as the industry, hopefully we'll address this. Thank you very much.
Thank you, Professor. That was interesting. I mean, I just heard one development. The brick can illuminate, generate, and have structural strength. I think that's something maybe you will immediately go in and start manufacturing that, I hope. That's a good one. And thank you. Maybe MCCI can initiate a forum where we can bring the architects and all together. Just to, I understand we have a panelist on the line. Just a last question to all of the panelists. We have till now done solar 100 gigawatts. Now we are talking of BIPV. Our target is 360, 100 in maybe 25 years, right? We have reached 100 gigawatts in 25 years. We are targeting 300 in the next maybe 3-4 years, 5 years. Possible, not possible? Quick.
It is very much possible because a lot of initiatives has been taken from the 25 years which we have done, because there was a kickstart required for solar, which has already been done. You need incentives everywhere to start anything. Now there is no incentives in any commercial space. I meet a lot of industries. Oh, they say that he has put the solar PV, his electricity cost will be reduced. Why you are not putting? So one of the customer was Vardhaman Industries, who are textile. They have still not started the solar. They have just started the solar last year, and now they are installing like insane because they know if you have to compete with others, you have to put up solar. And government initiatives is also there. So I think next 100 gigawatt you can see in another 2 years.
Maybe I'm not so optimistic, but difficult, but you need all hands in deck.
I think it's very doable. We have the scale now. The big picture thinking has entered into the day-to-day minds. It's very possible. If policies help us, it should not always be 1 step forward, 2 steps back. If it's go, it's go. It's not go, but that's not helping.
Yeah, academia is ready as long as academia is ready. There are 2 stakeholders, of course, like industry as well as the policymakers. If they are give proper funding, obviously we'll take it forward.
Thank you. That was a good one. And paucity of time, let's go into the panel, the online panelists now. We could move on. Loganathan, can we come down? Hello. Yeah, Mr. Hans, you heard us in this session?
Yes, I followed the conversation.
Yeah, you must have heard the challenges that were expressed, the opinions, the views on the policies, and the confidence of both the manufacturers that we can do 100 gigawatts in the next couple of years. So your thoughts, your views, whether India can move forward and take it up.
I'm very much confident that you can do it. I'm with some of the speakers, but I'm typically as a manufacturer, we like subsidies, but you also know and should learn from Europe when the subsidies went away, and you are not at scale, you suffer as a manufacturer. So you also have to have the outlook in the future and say, what's my business model when the subsidies go away? And I'm still profitable, and do I have a competitive product on the market? So I'm looking very much from an owner standpoint of a manufacturing side now, and do we survive after subsidies? That's for me my most important part when I go in a new business, in a new manufacturing. We like the subsidies. I just returned from the US. Some manufacturers said, wow, I was in business when IRA started and suddenly the money fell in my pockets. But am I still profitable when somebody comes in with 20 gigawatts and scales up very, very heavily? And I see my colleague from Vikram nodding. We must be very competitive in pricing. We need to scale our manufacturing, and then we stay for a long time and enjoy good business.
Thank you. Thank you, Mr. Hans. Just one last question. I mean, there was not much views on the logistics issues we have today in component procurements and manufacturing. Any suggestions you have for the Indian manufacturers?
Well, depending. In BIPV, we are typically very small, so we see not many issues in supply chain. So I have not really a good answer for that. The ecosystem and the supply chain obviously needs to grow with a demand in market.
Okay. Okay, thank you. I just thought maybe your experience into India could also help these people. Anyway, thank you, gentlemen. I think it was a excellent one. Hope BIPV goes forward. Any questions? Yes, ma'am. To whom the question? Or to everyone?
Yeah, so I would like to get an insight into from the manufacturing people. What is your commitment on recycling? Because that's a continuation of my question from the previous session. That is one. Is it going to be a general, be mindful of disposing this waste with a recycle symbol behind the box? That because that's a standard followed. Or what is the level of your involvement in getting back the product, as I understood from the previous panel discussion? The second thing is, are we really manufacturing products that last their life? Because, what is in it as profit for you from the manufacturing perspective? I'm not sure if that's too much of a question to ask, because none of the products that we buy last more than a 10-year lifespan. Because, a TV which I buy, at the end of its warranty period, it just switches off itself. So I would like to know what is the commitment that the manufacturing company is offering for a BIPV, assuming that we are still talking about, panels lasting 60 years of, the building itself. That is one thing. And then should we still call subsidies? Because I think we are still subsidizing the taxpayers' money for all the subsidies. So is it fair enough to still term that as subsidies? Because that would be the question I would like to pose to someone from the guidance team. That's it. Thank you.
Who would like to take forward?
Yeah, I'd like to speak on the longevity aspect of it. The 60-year number, I've not heard it in solar. Maybe from that comes from a building perspective. Whatever we build today, we want to build it for a long time. Today, as a manufacturer, I provide a 10, 12-year power performance warranty and about a 30-year product warranty. Performance is where every panel has a degradation over its lifetime. Even at the end of 30 years, it's still, like I said, some very well-made panels perform more than 90% of the initial nameplate capacity. That's what we at Vikram also strive for. The global industry has standardized to that level now. Point again I will enforce is, as long as we are using good materials, a good bill of materials, good processes, the panels will last. There's a reason SoftBank founder Masayoshi said, after 40 years, I'll provide free power for everybody. Why did he say that? Because in a lot of cases, solar is a fill it, and the Suzuki ads from fill it, shut it, forget it, right? You install, you keep it clean, it will work. Sun is going to shine, panels are going to output power. So that's the longevity aspect of it. Maybe some panels, there's always, you have to replace at some point, 1 in a million parts per million, parts per billion time frame. After 30 years, maybe you have to look at reinstalling if the panels start to go bad, which I don't think it will. But if you're looking at 60 and 70 years, there has to be a plan in place to replace the panels at that point in time. Today, we can assure you of a 30-year lifetime and more. 60, I don't think is proven yet. Like I said, I know panels made in 80s, which are performing today. That's still a 40-year-old panel. Vikram's panels have been in the field for 20 years now, and very few returns we get. So in that way, the technology has longevity in terms of lifetime. That is there. How do we extend it depends on materials and also the bankability of the process that the manufacturing company follows, which companies in India, I think, are becoming better at scale, better at replicability. That will also come. So on the other part about recycling, it's a topic whose time has come, just like BIPV. Recycling is still at the back of people's minds. When you have installed 100 gigawatt of solar in India and 1 terawatt, that's 1,000 gigawatt of solar installed globally. Even 0.1% or 0.5%, if it goes bad, that's quite a few 50 gigawatt of panels. That's billions of panels going bad. As an industry, we have to come towards having an organized recycle sector, recycling industry, which I think IIT has taken a lot of step towards. 90% of the panel can be recycled. Silicon can be reused. Glass can be reused. Frames, aluminum can be recycled. So there is technology to doing that, but not at scale. So in Europe, there's a PV cycle forum, which takes back panels for recycling. Likewise, in India, I think it's an idea whose time has come. As an industry, academia, we all have to get together to have a formal recycling program, formal recycling processes, people who can actually do the recycling. It has to happen, and right now it's still in nascent stage. Yeah.
Okay. Yeah. Two questions. One is
I'll add to this. So government has initiated an EPR program for recycling. So whatever you are manufacturing or whatever you are bringing out of India, so you have to bank it right now. You cannot go. It might happen that you are not recycling, somebody else is recycling. So you have to get the certificates from them. So that bankability is now in process. I don't know. It was not earlier, but it has recently started. Last, I think, 1 year or so. So now recycling would be promoted by somebody else. It might not be the manufacturers who are doing it, right? Because it might happen that they are actually not at a very good position, whereas the recyclers are at a very good position doing that. And what was your next question?
That's all. It was to guidance Tamil Nadu regarding the subsidies.
So on the subsidy, right? I'm going to talk about the adoption subsidy, the subsidy that we give for, let's say, manufacturers to come in. Now, we did an internal study. The subsidy, is it the first important thing for them to come, right? Answer is no. Okay. The most important thing for some of these companies is infrastructure, ecosystem, and then subsidy, right? So if you have some of these first 2-3 things sorted, you really don't need to give subsidy. But the problem here is, why do you give subsidy? The competition is so high. If I don't give, my neighboring state will give. Okay. So you're upping the game only because there's a competition so high, and we all need to create jobs, right? But subsidy is not the top of the thing of manufacturers. If you do other things, if you do the ecosystem, if you create great talent, if you're able to provide them infrastructure, they don't care.
Yeah. The first question is the scope for MSME in the manufacturing value chain. So you can throw some light on that. Then the second question, I don't know whether to can I ask it about the corruption in specific to rooftops and utility scale thing is heavily lobbied. People are crying. So
As I began, not the right person to talk about anything on energy and electricity because I'm not from those departments, so I have no clue. But of course, this rent-seeking behavior, is pervasive not only here but across multiple states and the country. Now, I'm sure I don't know if there was discussions in the morning. I mean, there are conflicts within, let's say, different interest and so forth, right? As a system, you are more inclined to do large projects, thermal projects, and so forth, than focused on decentralized solutions, let's say BIPV or solar or wind and so forth. So until and unless those value conflicts are resolved as an institution, and you'll not be able to kind of come out with these solutions. Point number two, you're cross subsidizing heavily. Pricing is a good mechanism, right, in terms of resolving some of these debt in what you see here. One of the highest debt in the country in terms of the Discom. Now, if more and more CNI users are going out, and you charge the highest from them, and your consumers, residential, you have not even reformed in terms of pricing. We are the lowest in terms of the pricing, right? So you will not be able to kind of come out as an institution, from the kind of challenges you inherently have, to the challenges you have in terms of what's your vision, what's your value, and if you're unable to resolve some of the value conflicts, then some of these things will continue for the longer run. So I think internally a lot needs to go in terms of reform, in terms of ideas, in terms of strategy. Again, I think energy department and all of them must be working. I mean, I saw in the news 2 days back that battery as a storage, someone was talking about it. The department is going to roll out some of these proposals and call for RFPs. So, there is, I think, some, a thought process being taken up there. But yeah, I agree with you. A lot more needs to be done.
Thank you. It's a very interesting question which you had asked regarding MSME. Because most of the companies in solar sector are also MSME. There are only 100 or 50 who are large manufacturers, large developers, and businessmen. All the jobs, all the innovation, all the customization only will come from MSME. I am not expecting Vikram or Wari to go into customization. They may standardize something, bring down the cost, but BIPV, if you see from European perspective, there are 100 BIPV module manufacturers, and none of them have a capacity more than 100 megawatt a year manufacturing. Why? Because a small player with 100 megawatt of manufacturing capacity can easily provide solution to the nearby market and will be able to add all the customization that is required. Initial input cost is already at its lowest. So it's the customization which is costing you more. And for a large manufacturer, it's only the scale that work. But for a small manufacturer, it's the value addition on the customization and meeting the requirements of client which will work. Both is benefit for the industry, because if there are big projects, they can go for a larger one with the standard one. If there are customized things required, they can go to the smaller who can give the boutique solution. So this is also the power of decentralized, So you are not going into targeting gigawatt scale land parcels, but you are targeting one building at a time, which may require 3 design, and nobody will provide that solution apart from an MSME. Thank you.
Yes.
Good afternoon. Yeah.
Okay, we have a couple of more questions.
Okay.
Because Martin has got a
This is-
summary. Yeah.
This is more than a question, it's an observation. According to the DCR, the development control rules of the government, the CMDA and all that, we, in case if a structure, like say the square feet is more, the terrace has to have a 1/3 or a 1/4 area covered with solar panels. So that's a you have to get a completion. When you have to get a completion certificate, you will have to actually have those solar panels on the terrace. But I don't want to mention the builders' names and all that. But the projects, a lot of projects, what I've handled is, what I see is it's a namesake setting of a solar panel on your terrace to get a completion certificate. And finally, it doesn't exist in your site. So this is what is happening to a lot of builder projects. So it is being transported to the next site. So that's what is happening. So,
solar panels for rent.
Solar panels for rent. So how do we regulate this, or how do we make a control to it? Like say the government has to monitor every 1 year on how the grid, it's been connected to a grid, or so how do we address this?
No, I think I'll answer this question. I think CMDA has already started regularizing this. They've started doing a drone survey of all the buildings, and they've, in fact, I participated in one of the meeting. What they have done is, okay, you have taken an approval showing this, you have done up so much of solar panels. Either paid that as a fine or install same capacity of solar panel current day. So I think this initiation has started already, and slowly we will have all these things done.
You'll always have some corners which are cut, but
I have one direct question. I'm not sure whether this is an apt question or not, but then I'm putting it to the manufacturer as well as to Mr. Arvind also. What is the range of power generation, kilowatt hour, when compared to the horizontal surface and vertical surface?
So if we put up in a pure south for a
range
horizontal surface, according to the azimuthal calculation, it is approximately 4.4 unit per day.
Kilowatt.
Per 4 units per day.
Per kilowatt
kilometer
per
hour
day,
per
yes.
day. So in this, what we have been able to see is with vertical, it comes out to be approximately 2.7 unit per day.
So roughly around 55%.
Yes, that is what.
One more? Please go ahead. We'll have the last question, because otherwise we should not delay lunch. I think.
Hey, thank you. My name is Hari. I work in Asar. Just to answer Madam's question, I think one way to ensure that the regulations for the CDBR happens is that the interdepartmental collaboration between CMDA and the TANGEDCO, because CMDA's mandate ends once they give the completion certificate, and then it becomes the departments to give the connections for grid connection and so on. So that if there's a interdepartmental communication or a cross collaboration, then I think that should be something, and they're already doing that as per the fact. But one question which I want to speak very specifically to Tamil Nadu's context, with challenges of adaptation of rooftop solar, though we know Tamil Nadu has been a leader in renewable energy, specifically solar, almost only significant, only 10% is from rooftop solar, and BIPV will more probably fall in that sector as well, right? How do you expect with very good financial models, subsidies, regulatory frameworks, so much for the central government, state government as well, with solar rooftop not picking up to its potential in Tamil Nadu? Where do you see BIPV coming in? How do you see that crossing the same path as the rooftop solar has gone through? Like, how do you see that it will cross those hurdles and then adopt it on a large scale or in a bigger way that you're expecting?
I'll take this question on behalf of all of you. If you go on ECR road, you'll find a number of independent houses. In my opinion, if an independent house has not put a rooftop solar, they're losing money, because rooftop solar for independent houses is just required to be done. You save, it's very easy to do it. You have no regulations, it's simple, it's a process going on. The biggest challenge here is awareness and confidence. When you talk to anybody, I've talked to a number of people, we are part of the EMA also. We try to push people, independent houses, small apartments, 4 flats, 7 flats. even built up already ready apartments which are occupied. If they're not going in for solar, they are losing money. It's as simple as that, because the government subsidies are excellent. The opportunities are good. You don't need too much regulations there. You have regulations where in other areas, but in these areas you don't have. That itself is an open challenge. Straight away people can go in and do it. It's awareness, and it's the initiative to go forward that is required. If that is there, I'm sure we can do it. You go to any other, you go to Gujarat, I'm sure you'll see everything is solar. I mean, I'm just taking a good. You go to Andhra Pradesh and Visakhapatnam, it's solar. We can do it. It's absolutely nothing stopping us from doing it, right? So it's just the awareness, and I'm sure today's session has been good. I think one of the key objectives was to do awareness for today. I think that's taken off, and also towards the awareness, the challenges that the manufacturers, the technology, and from the policy makers, I think all are in tune. It's just that we as a group need to move forward with all the stakeholders together. With this, I will now hand over to Martin for doing the summary, because we are getting late into the lunch. Thank you.
Yeah, maybe I would request Martin to just give a moment or to our panelists as well. Thank you, panelists, for your insightful session. I would request Martin to give it to Professor Mr. Suri. I said Professor. Yeah, Mr. Suri, Suri Narayana Rao, sir. Thank you. Yeah. Thank you. Thank you, Martin, to Mr. Venkat Rajagopalan, sir. Thank you, Mr. Venkat. Yes. Professor Reddy. Thank you, Professor, for joining this event. Yeah. Thank you, Mr. Gaurav. Thanks for your time today. Thank you, Arvind, coming all the way from Delhi. Thanks for your time today. Yeah. Over to you, Mr. Martin. Thanks.
Yeah, this is to conclude the session. I think we had a very insightful and inspiring session on building integrated solar. I know I stand in between you and lunch, so I'll keep it very concise. To start with, I want to extend my gratitude to all the speakers, the panelists, and the audience. Specifically, a thank you to GIZ to bring this program to Chennai. And of course, to the Madras Chamber of Commerce and Industry, the team has done all the heavy lifting to make this program a success. So I have a few learnings that I wanted to share with you as a takeaway. One is the emphasis on skill and capacity building and having a dedicated team of professionals that looks into building integrated solar. The second learning I take away is the emphasis on local supply chain, manufacturing, and having a vibrant ecosystem. And I hope Tamil Nadu could lead the way in that. The third one is, of course, we discussed a lot about codes, building regulations, and policies. I hope that you're all inspired and that you start incorporating some of those learnings from the day in your practices, be it as a planner, an architect, or a policymaker. I have also learned that we have one profession that has the longest list of questions, which are the architects. That's on a lighter note. Thank you all for coming, and I hope you enjoy your lunch.